have you all in person here. If you see in real life, like AI has become an integral part of our life. When you take entertainment like Netflix or e-commerce like Amazon, or even in a coding day-to-day life, we use Copilot, Claude, Jenkins. So everywhere you go, AI plays a dominance, whether it is directly or indirectly. So it is very much important, like we should know the technicalities of the AI to use the tools better. Also, to innovate the new tools, because you see, like there were times like we're using AI products. Now we start to build AI products. So it is very much important to know all the things. And with that concern, like we started the AI Connect. So I call up Sudha to share like how it started and its initiatives.
Good afternoon, everyone. It's a pleasure to have you all here. I can see the passion and the curiosity that you have. Okay, so I can see from the amount of people who have gathered here. Sorry again. Okay, so we know meetups is all about having the like-minded people to gather in a place where we could share ideas, learn each other, and network, connect, and collaborate. So in order to fuel our activities for the AI Connect, we need the collaboration. That is the cornerstone of any progress. So the TAI Connect provides us with all the projects, all the connects that we hook up, the experts sharing ideas, we have all the discussions, and so we learn from each other. These are all the important progress that we can share with an AI progress. That's what and the TAI Connect gives us. And once again, I welcome everyone and thanks for being here. So let's connect, discuss, and innovate. Thank you.
Yeah, thank you, Sudha. So being a two-year-old company, Talentship, we are proud to host a first TAI Connect event, and we are even more prouder to have Oliver, our CTO and founder, to be the first speaker of the session. So to know about Oliver, he's having around 25 years of expertise in creating IT industries with a large crowd of around 300 people. He's also having a large expertise to provide AI-based strategies and solutions. He's also a renowned public speaker who shared his AI-based topic experience at the Fraunhofer Institute and more on. He's also an author in sharing his ideas for over like large amount of IBM Red Books. So without no further delay, I call Oliver to take his stage.
Thank you, Devi. So I'm just going to switch here to my screen, and then we are ready to start. 1 second. Just have to share my screen. So first of all, welcome everybody to the first installment of our AI Connect. My name is Oliver Trabert. I have been a CTO for the last 25 years, and since 2018 I've been doing a lot in AI. So long before generative AI made AI somewhat mainstream. Yeah, so we have been doing AI since 2018, but back in the days it was way more effort than it's today with the new large language models. And what I would like to do today is to actually give you an introduction on what is generative AI, how do these models actually work, and then later in the day we will actually show you how can we build really sophisticated applications that really bring value to the users. And today there will be a lot of code which Farook and Maha will later share. So my talk will be more, first of all, on the concepts that we all need to understand to really make a sense of generative AI. So for most people, I would say generative AI is actually synonymous with ChatGPT. And the reason for that is pretty simple. So in this illustration here, I'm actually showing how long it took ChatGPT to get 100 million active users. And it took it 2 months. Yeah, and if we compare that to other well-known and used applications, TikTok, 9 months, Instagram, 30 months, Uber, everyone was talking about Uber. 70 months to get to 100 million active users. Yeah, that's quite impressive. So what we can clearly see is that this is a tool that really adds value to the users. And let me ask, who's using ChatGPT or other AI tools on a daily basis? Just raise your hands. Ah, good. That is actually very positive, because that will be the future. Yeah, people not using Gen AI tools will be replaced by people who use it. And the reason is it makes you so much more productive. Yeah, it actually can help you take away the tedious work in coding. It can help you to explain if you have a bug or an error, what the reason might be. It can explain to you how certain concepts work. Yeah, so it's really, really a powerful tool that's transformative, and it's going to change the world. And it's all based on what we call the generative pre-trained transformer. Yeah, that's what comes in ChatGPT. So you can clearly see it's a technical name. Yeah, it wasn't invented by marketing people. You would never have called it ChatGPT, yeah, because it wouldn't make any sense. You would have given a fancy name. But it's all about generative pre-trained transformer. Let's actually try to look into what that means. And first of all, a transformer model, that's a neural network architecture. Yeah, and it automatically converts an input into an output. That's basically its purpose. And originally it was invented by Google, and it was invented for the purpose of translation. Yeah, so translate from one language to another. Yeah, like here from French. Je suis étudiant means I'm a student. That was the initial purpose of the transformer. But then it actually turned out that the transformer cannot just translate language. It is basically an everything to everything else translator. And that's an important point, and I have an image here to illustrate what I mean by that. Where we usually use a large language model, yeah, or a foundation model, we always think in, I have a question, it provides me with an answer. But we recently have seen it can actually create music. Yeah, from a prompt, I create music. Zora is now creating from a prompt a video. But this goes actually far beyond, because if we look at here, there's like really, really interesting elements, like what I have here. What if we were able, from an input, actually to create, for instance, DNA? Why shouldn't that be possible? DNA is yet another language. It's an encoding. It's very similar to the images that we have, or the video that we create, or the music that we create. And this actually opens the door to a completely new world in biology. Yeah, when I'm suddenly able to describe what kind of protein I need, which capabilities I need from this protein. Yeah, and we now have all the tools like that we have seen during Corona. We suddenly had vaccines like with mRNA. And you can now imagine that you basically describe what kind of mRNA you need, and then we're actually able to produce that. And that actually opens the way to synthetic biology, for instance. Yeah, so the transformer goes way, way, way beyond on what we are currently seeing. And the interesting thing I always try to mention in these talks is we are talking about, in essential, 100 lines of code. Yeah, the transformer, in practice, if you take away all the framework and supporting code, it's just 100 lines of code. And that is basically changing the world, because it's allowing us to transform everything to everything else that can be described basically in a language. DNA is a language. Yeah, music is a language. Images are a language. Yeah, here we just have pixels, yeah, with a certain encoding. So this is actually really huge. And then you see also robotics. Yeah, we then suddenly put the LLM with all its capabilities into a machine, and suddenly we connect it to the real world. Yeah, so the transformer is really the fundamental that is driving all the change in the future. But what I would say is, what we will see now is, especially with this DNA, this is basically opening a revolutionary way. Yeah, so far, people estimate that evolution in 300 million years only basically explored 1% of the possibilities in biology. So 99% of biology are still unexplored, and the transformers will open the way to explore all these 99% possibilities that nature and evolution haven't really tapped into. And here are just a few examples. What we can do is, and I already mentioned that, yeah, question, answer, language, image. So let's look at an example. Yeah, so here I just describe what kind of scene I would like to have, yeah, like dreamy waves in style of photo taken on film, yeah, and off it goes. Yeah, and this is way before Zora. Yeah, this is basically 6 months ago that I was already able to basically do these kind of videos. And we are just at the starting, and also with Zora, we are just at the starting point. Yeah, so it will enable pretty much anyone, yeah, to create their own movies. I think that will be a big impact on the filmmaking industry. Here I have another example where we basically do a functional MRI, which is a brain scan. But before I basically get into this example, let me just quickly explain what's a functional RMI. So it's a magnetic resonance imaging. So it's a non-destructive way to basically, through magnetic fields, to see what is going on in your brain. So we can visualize your brain activity. Yeah, so pretty cool. And that is basically done by observing what is the level of oxygen, yeah, that your cells are using. And this way we can see what areas in your brain are active. So now what we can do is we can have people in the MRI and we show them images, like of animals. And here you actually see what's happening in the MRI. Yeah, this is basically what we recorded. And what you now will see is that through a large language model, through a neural net, we are actually able to decode that image. We are able to look into people's brain and see what they think. And that is quite amazing. Yeah, of course, today you have to be in an MRI machine, but that's always the beginning. It will become more and more simple. Yeah, and if we basically look at what is Elon Musk doing, well, he's doing Neuralink. That's a brain-computer interface. Yeah, and by accident, he also was the founder of OpenAI. So here you see how this, in the end, all comes together. Yeah, how suddenly then the capabilities of the machine learning model, yeah, can suddenly basically be fused with the actual human. Yeah, here we still need a brain implant. I'm pretty sure that maybe in the future we won't need that anymore. Initially, this is obviously for good reasons. Yeah, it's for medical improvement. People who basically cannot see anymore or speak anymore with Neuralink, you basically can bridge that. Again, yeah, it's through the large language or the foundation models which make this possible. And this actually raises an interesting question. And yeah, so who is actually going to protect your inner dialogue? Yeah, so maybe in 5 years I'm standing here, know exactly what all of you are thinking. Yeah, so what are you thinking about? Yeah, the guy standing here and giving this talk. And it's just a little bit food for thought. Yeah, maybe think about this also after the session. Yeah, what kind of challenges this will actually introduce. Yeah, and we are already very close. So if you look at ChatGPT-O, yeah, for Omni, yeah, it now basically can read your facial expression. It understands the emotions in your voice. Yeah, so these are all early states of what is actually going to come. And at the end of the day, we will have a big problem in 10 years, yeah, how to actually protect our inner dialogue. But let's actually get away from the transformer and actually look how does the pre-training work. And the interesting thing is, pre-training is based on a large corpus of text. So we're talking about 300 billion words. So pretty much the entire internet, yeah, and beyond, books, everything. And the way that we train the model is that initially we basically have the weights, that is basically the neurons in our artificial brain, they're all set to 0. And what we then do is we actually show the model the 300 billion words, but only 2 at a time. And we always ask it, what is the third word? Yeah, and then it's actually going to start with a wild guesswork. Yeah, it's just going to guess words and words and words and words. But if it's guessing enough, eventually it actually found the right word, and we are going to update the weights in our model. And if we do this 300 billion times, yeah, then we end up with a weight matrix which looks a little bit like this. So this is not 0, it's already a trained one. Yeah? But the matrix in practice is like much more complicated. It's probably 12,000 by 12,000 dimensions for GPT-3. For GPT-4, no one knows. And this is just the first layer in the model. Yeah? In practice, we then have, in GPT-3, 69 of these layers. And the interesting thing is that in each of these layers, basically we execute the exact same exercise. And by coincidence or by mathematics, that actually then leads to all these fantastic capabilities in the model. And I'm going to explain in a minute how that actually works. But it's important to memorize, we actually start with an empty weight matrix. We basically 300 billion times guess words, yeah? And all the time we update our model until the word prediction is correct. And in the end, we have a pre-trained model. That's as this works. It's pretty, well, it's not very sophisticated, but it's very surprising that it then has all these major capabilities, yeah? And the question is, how can it suddenly summarize text? How can it basically understand language? Yeah, how is it able to reason? I think that's a fair question, and we're going to get to that in a minute. But it's a super stupid, simple process to pre-train the model. Yeah, and in the end, we have a model. Yeah, GPT-4 has like 1.5 trillion parameters. Yeah, that's like an unimaginable large number of parameters or weights. Yeah, and the next step is then we need to get into fine-tuning. And fine-tuning is when we basically teach the model what we feel is right or wrong. Yeah, so we ask questions to the model responds, we say good, bad, and provide feedback. Yeah, and we do this a lot of time. The interesting part is, obviously, this is like basically raising a child and teaching it. And at the end of the day, what's I think important to remember is, well, we actually create like an ethical and moral compass for the model, because that's how we taught it. Yeah, it's the same with your child. Yeah, the belief system you teach your child is how the neural network in your child will later behave. That's exactly the same with these models. Yeah, and at the end of the day, that also again raises interesting questions. Yeah, should a company like OpenAI really define what's good or bad, what's right or wrong? Yeah, just put a question mark. Yeah, and you will actually see that in different regions of the world, in the future we will need different fine-tuned models. Yeah, because the belief system in India might be different than in Germany. Yeah, and I guess everyone wants to be really represented with a model. But as of today, it's basically more the Western mainstream bias that these models follow. And you can try that by asking certain questions on climate change or whatever, and you will see what is basically the training that the model went under. Let's actually get to these capabilities I mentioned earlier. And the interesting thing is, the larger the number of parameters that we have, the more weights we have, the more capabilities emerge. Yeah, we haven't programmed them. Yeah, no one programmed ChatGPT to understand arithmetics, to summarize text, to do translations, to do pattern recognition, to do reasoning. None of this was ever taught to the model. The model was taught to predict the next word. So a major question is, how is this actually happening? And this has to do with a concept that we also see in nature, which is called emergence. And emergence refers to the phenomenon that certain properties of a whole cannot be explained from its parts. Yeah? So we cannot explain how it works, but it works by the sheer size. And an example is, in nature, if we look at an ant, then you actually see, oh, the ant, it has certain capabilities, it has certain skills. But if you have 1 million or 100 million of ants, the ant hive has much more sophisticated capabilities than this one individual ant. And that is emergence. Suddenly, 100 millions of ants are able to do complex constructions, to construct air conditioning in their hive, have food chambers. And that basically is a capability that emerges through the sheer size of the individuals. And that's exactly how we have the emergence of capabilities in the large language model, by just scaling the number of parameters. Example. So here is, for instance, the capabilities that we have at 8 billion parameters. But if we basically look at 60 billion, that's already many more. And if I now basically let this run, it goes up to 540 billion. You see these capabilities emerge. And that's why emergent capabilities is exactly how the models work. And that's why OpenAI constantly tells everyone that they will achieve AGI, because it makes sense. Because if I'm able to scale it, let's say, from 300 billion to 1.5 billion, and have the jump from GPT-3 to GPT-4o, and now I say I scale this 10 times, and what if I scale it 100 times? And that's exactly what they're doing. Why are they actually building a supercomputer for $100 billion? With 100,000 GPUs, which require like 3 nuclear power plants to power. The reason is that they want to build AGI, and they expect emergent capabilities to emerge, that we can't even imagine today. And that actually means we need to ask the question, at what point is GPT actually going to surpass the human capabilities? Because eventually, if we follow this logic, this might happen. Or we actually run into some dead end. We don't know yet at this point in time. But just to give you an idea. And if I quickly basically go back a few slides, so then just to explain, so basically when we started here at the simplest level, so then all the rows and columns, basically every row represents a word in your vocabulary. And basically everything going down here basically is then the relation of all the other words. So that is basically how this matrix is built. And we start very simple, and the deeper we go in the network, the emergent capabilities, they happen deeper in the network. The deeper the network, the more parameters you have, that's where that's coming from. And that's why you need this massive, massive, massive compute. So down here, the model is like super stupid, and it gets more sophisticated along the way. And ChatGPT-3 had like 96 layers, and GPT-4, they probably will not tell us. But just to give you an idea how it actually works. So the smartness happens basically way, 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 way deeper in the model. And that has to do that through statistical, mathematical events, we actually have this emergence of these fantastic properties that we use every day. So just go back to this slide here. So, and of course, I would say OpenAI is like one of the only companies that has the marketing where they warn about their own product. So Sam Altman is constantly traveling around and telling everyone how great the product is. So I guess it's the first marketing where you have to basically warn people about the capabilities of your own product. And I'm not sure how the coverage is in India on any of these, let's say, challenges that the models might introduce. And then, of course, yeah, we can use this because we are all software engineers. We can use GenAI in software engineering. And there's a recent study from GitHub, and it actually shows that it makes an average mid-level developer the coding 55% faster. 46% of the code gets already generated, and 75% of the engineers feel more fulfilled because you don't have to do the tedious work. And the classic workflow that I used to do myself in the past is, oh, I need to do the following, Google, Stack Overflow, found it, copy paste. This is a much better copy paste pattern, much more sophisticated. But don't get me wrong, experience can only be replaced with more experience. And what we are seeing on this graph here is that we basically see that engineers with less experience actually benefit most from using such a tool. And the longer your experience span is, the fewer you will actually benefit from it. And the reason is that the model is a generalist. And if you are specialized in a certain area, at this point in time, you always will be better than GPT in writing code. But nevertheless, as the numbers indicate, it's like a huge, 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 huge way to reduce the tedious work so you can concentrate on what's really interesting, what's important to you. Not on, I don't know, writing a simple function that Stack Overflow also would provide. Just as an example. And then this whole Copilot thing expands way, way, way beyond just coding. It gets then to Microsoft Teams to summarize your meeting, in Outlook to summarize your emails, in Word to help you create content. And you probably have all played around with it, and it doesn't matter if it's embedded in a Copilot or if it's basically just ChatGPT or Claude, for instance. And I guess the interesting question is then, well, how can we actually build our own Copilots or our own expert chatbots? And I actually brought you an interesting example of a chatbot that we built, and it's a medical expert chatbot. So I didn't want to take any trivial example, so a more sophisticated one. And this is actually from University Clinic of Essen. That's one of the leading university hospitals in Germany, and also one of the main drivers for AI and innovation. And this is an assistant that is used in the neonatal intensive care unit. And what is neonates? Well, that's actually babies born very early, so starting at 23 weeks. Just to put that into context, usually a pregnancy takes 40 weeks. So it's actually very, very, very early born child. And you can imagine that this has like very different treatment and medications than you would find in any other infant. And that's what makes this somewhat complicated. And at university hospital, it's a teaching hospital. So every 3 months, you basically have like a new rotation of physicians who want to become pediatricians. And what they actually all have to learn, and I'm just going to show that to you, is this is just a very, 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 very long document that everyone gets that starts there. And it starts here with all the different medications that we have. And it then goes along with all the treatment schemas that we have and so on. And you can see this actually can get kind of complicated. It's actually not easy reading. You actually need to spend a lot of time and energy to read that and to learn that. And who these days actually has the time? If you go to a hospital, then doctors are notoriously overworked. So what about if we could create a system that is an assistant to the doctor and actually going to help them, with all the expert knowledge of this content? And that's what we did. So I'm going to just quickly go back, and I have an example for you. So we're going to look at the medical expert. So here's an example. So let's assume we have like a 6-month-old child, so a really newborn, and it needs to receive this antibiotics here, Caspofungin, yeah, not a medical expert, but that's basically what it needs. And then you need to know, okay, what's the weight of the child and what is basically the height, because that is then really dependent to calculate the correct dosage. And if I now switch quickly to my assistant, yeah, it's not very sophisticated. Assistance is like input-output, so let me quickly get the question. So I'm just copy-pasting it so I don't do anything wrong. Go back to my window here, put that in, and let's see what the response will be. And the interesting part is that it's now going to use the information, yeah, and it's actually going to come up, well, it is going to explain the reasoning, how it got to the conclusion. Yeah, it's not just giving me the result, yeah, you need to use this much. It actually shows us exactly, yeah, what information did it actually take? How did I reason about what it needs to do? Because here, for instance, you need to be aware that the weight of the children is not that relevant. You also need to calculate the surface. And it was able to understand that in this case we first have to calculate the surface because the dosage relates to the surface. Yeah? So we suddenly have a system, yeah, that is not just a generalist doctor, it's an expert medical advisor for a very complicated field, which is neonatology. Yeah? We can also make yet another example. So you get the idea on what actually these systems can do. And what's super important is that this shouldn't make decisions by itself. It should be an assistant, it's helping, and that's why it's so important that it explains what its reasoning was. Yeah, so how did it conclude at a certain dosage, at a certain treatment schema? And I think that's exactly what's going to be relevant in the future. Because initially everyone has heard language models can hallucinate. But if I hallucinate in the dosage of such medication, that's a decision between life and death. So this cannot happen. So first of all, it's important that we're able to ground everything in the information provided, and then also add the reasoning on top. And this way, we are able to create expert systems, yeah, which are actually extremely sophisticated. And this tool is actually used on a daily basis at the university hospital. So I just wanted to share that to give you an idea what are the kind of systems that we can build already today. Now the question obviously becomes evident, yeah, how do we do this? Yeah, I already mentioned, yeah, so ChatGPT and also Claude, all these models have some base knowledge in medicine. But at the end of the day, to make them an expert, you need to provide them additional information. And the concept to do that is called Retrieval Augmentation Generation, RAG. It's a somewhat awkward word, but in practice it means you take information that you have and you make that available to the language model, yeah, on top of what it already knows. That's how this actually works, because this allows then your language model to become an expert on your content. Yeah, and this is the same like in an enterprise. Yeah, if you want to have an expert as an HR advisor, yeah, in an HR department, then you need to be able to take all the policies from the company and make it available to the language model. Only then can it give an answer that's actually grounded in reality of a company. Yeah, so just as an example. And this retrieval augmentation generation, here's just a high-level explanation on how it works. Basically, the user has a question, yeah, then the LLM, we in our code, we retrieve the relevant context information and then send the relevant context information together with our question to the language model. And the reason why we have to do it, let's assume you have 1,000 or a gigabyte of content. Yeah, you can obviously not send all of that content to the LLM and ask your question. And the reason for that is there is this concept of a context window. And context window is basically the input and output combined that the language model can process. And that's limited. Yeah, in the most advanced cases in the API, it's 200,000 tokens, and a token you can think about as almost a word. Yeah, so it's probably 150,000 words. So if we basically have like a gigabyte of content, yeah, it's not feasible to send all of that to the LLM. So we need to find a smarter way to identify what is the relevant information and send that to the LLM together with our question. That's also what we're doing in this medical example. Yeah, we cannot send the entire 150 pages each time. Yeah, we want to answer a question. It just doesn't fit into the context window. So what we need to do is we actually need to prepare the content, so we need to cut it. Meaning we have like these huge documents illustrated like here, and we basically come up with a strategy on how we cut it into pieces, and then we vectorize that. Yeah, so what does this vectorization mean? So, but first as an example with a chunking, yeah, so we take the text, let's say we go by paragraph, and then we create chunks in this example for each paragraph. So then we need to vectorize it. So, and vectorizing means we are putting it into a vector, which is a semantic representation of that content. And this is how the whole LLMs work. Yeah, so this matrix that we looked at earlier is basically a tensor. It's a multi-dimensional vector. Yeah, so vectors is the important element in any language model. And here's an example, just to start very simple. Here's like the vector for the word king. Yeah, so it looks obviously not very meaningful, but what it actually means is that each word is represented by a vector, and then in the vector space, what we find is that words with a similar meaning are close to each other. Yeah, meaning that here king and queen and man and woman, yeah, or walking and walked, they are close in the vector space. And the vector space, I said earlier, is like a 12,000 dimensional vector space, but since we cannot imagine it, at least I can't, this is basically a 3-dimensional representation of the concept. Yeah? So at the end of the day, the vector has a semantic representation of the word and of its meaning. And that leads to similar words with similar meaning are closely related in the vector space. That's the only thing you need to memorize. And then we can calculate the distance. That's just a mathematical function to calculate the distance between two vectors, and that is actually the cosine distance. Yeah, that's just basically very simple. And the smaller the angle, the closer they are in the vector space. And that is true for 3-dimensional, as it's also true for 12,000 dimensional spaces. Yeah, so that is the key principle. So, but back to the vector for king. So to make it a little easier, here's a color-coded representation. So you actually saw that all values here are between -1 and 1. And what I did is I just color encoded that to visualize it. And what I want to visualize it, I give you multiple words like king, man, woman. And I earlier said we have a semantic representation. And we can see this clearly here, that there are certain elements, yeah, that are actually very, very, very similar. So we see the similarity between king and man and woman. Yeah? And you can now notice that men and women are much more similar to each other than they are to king, just by the visual observation. And that means semantically, yeah, there is a stronger connection between man and woman than it is with king. So and if we now go this a little further and we say we have queen and woman and girl and boy and man and king and water, then you would say, my goodness, water, that's completely unrelated. But it is not. If we look here at the red, you actually see, oh, water is also related because water relates to the concept of humans being made of water by like 80% or even more. So semantic representation basically provides the meaning, and the closer things are related, the closer they are in our vector space. That is the key principle of all the language models, which you always need to remember, because that gets very important later when we want to work with that. So now an example here. King minus man plus woman equals, who's the first one? Queen, here. Where's a goodie? So, someone gives this here to the first right response. Queen is right. So, every time something's right, you get a goodie here in the session. So, yeah, that's exactly how it is. Yeah. So, if we illustrate this, and again visualized, yeah, king minus man plus woman, yeah, and if you do it, it's almost queen. Yeah, almost. Yeah, not 100%. But this is only done with like a 50-dimensional vector space. But in practice, the LLM uses 12,000. But that's too difficult to visualize. Yeah, that would be would look even more awkward. So now back to what we actually have to do. And what we have to do is we have to take our content, we have to chunk it, and then we have to store that into the vector space. Yeah. So now, this concept also works not just for words. It also works for sentences or larger chunks of content. Yeah, and I would say the larger the vector, the more it can basically have the semantic encoding. Yeah, meaning a 12,000 dimensional vector can have much more semantic information than a 50. Yeah, so, but what we now do is we basically take the chunks, we vectorize them and put them into our vector space. And now if we want to ask a question, what we can do is, we can also vectorize the question. I have vectorized the question, and now I basically measure the distance between the vectorized questions and the vectorized chunks. And the ones that are closest have a very high probability to answer my question. Yeah, when I basically take this away and my question is over here, I will not be able to answer it. Which also says my expert will not be able to answer all questions. It can only answer questions if the question is related to the content. And that's like a absolutely super important thing to remember. You always get an answer, but the answer might be wrong, but we will see later that you also get the probability, yeah, which is basically the distance between what you ask and the content that you have. And if the distance is too broad, then the answer is for sure wrong. Yeah, so, but what's important to memorize is we basically take content, we chunk it, we vectorize it, we vectorize the question, we find the closest chunks. Let's say the 3 or 5 closest chunks. Then what we do is we glue them together. Yeah, we just take the 5 chunks of content, we just chunk them together, and together with the question, send that to the LLM, and that answers the question. And that is exactly how this medical assistant works. Except that in practice, everything is always a little more tricky, because the chunking is essential. If I chunk at the wrong point, I just get garbage. Example. If I basically have this content, I need to be aware what is the information that goes together and needs to stay together to provide a meaningful answer. And if you cut a table in the middle, you will never in the world get a meaningful result anymore. Yeah, and that is like the most tricky thing in this retrieval augmentation is the preparation of the content. Yeah, it's a little bit, you can think about like an ETL process with data. You extract data and you need to transform it in a way that you later can answer the question. So if you do anything in data, you always need to think from the past, basically from the end. Which questions do I want to answer? That basically helps you to understand how do I do my data transformation and do my data modeling. And that is the same here. So in practice, you can think about chunking a document as doing data modeling. Yeah. So, but if you chunk it correctly, yeah, so you actually have meaningful chunks, then you are in the situation where you have a question, you find the meaningful content, you take that together with your question, send it to the LLM, and you get a fantastic answer. Yeah. On top of that, you also need to have a good prompting strategy, but I guess that would be go too far. Mohit. Hold on, I think we need to do the following and give you a microphone so that also the audience in the YouTube stream.
Thanks, it is a nice
session closer.
Yeah, so it's a nice session going on. So I have a query, it's not query, like I just want to add, like it is like if I don't expose to some kind of information, I will not be able to answer.
Yes.
So vector means like I'm in a different place and I'm not exposed to those. And if my vector is within this near to vectors, then I will be able to answer.
Yeah, you will always be able to answer if your question is related to the content. And if it's not related, and you get a probability for that. Yeah, it's basically your cosine distance. If the cosine distance is too far apart, then you need to tell the user, I don't know. Yeah, and that is super important, because if you then force the model to answer, it will come up with a fancy answer, but it will be wrong. And that is actually happening when you see like all these chatbots, and there's a good example. Canadian Airlines came up with a chatbot, yeah, and then that chatbot started to invent a new refund policy because the user tricked it into doing that. Yeah, or a car dealership in the US had a chatbot and it actually sold a car for just $1 because someone convinced it that he was Sam Altman and that the model should please do whatever he was asking. Yeah, so you need to be careful that that these kinds of systems also need proper you basically need like a real governance for it. Yeah, you always need a lot of quality assurance. You cannot just basically implement something and then give it to the users. You always need to collect their feedback and from there refine what you have implemented. Yeah, so I would say at first try, you get it 80% right, but the last 20%, as always, will be 80% of the effort, like with any other implementation.
One more thing I would like to ask. So basically, like these chatbots, they have the source, which is the internet. So if some data is not there in the internet,
yeah.
So then these chatbots will not be intelligent enough to answer.
No, that is why we basically take all the content that is relevant to us, and we basically provide that as like a kind of memory to the chatbot. Yeah, and this way we ground it in the information that is specific to us and that he has never seen before. Yeah, so that is how that works.
So basically, like this information, you show us two-dimensional, then three-dimensional picture where like you are saying information is increasing.
Yeah.
So basically, this information is stored like, because in our brains. It's
no, this is actually all stored in a vector database. So this is not stored in the LLM. It's basically, you can imagine it like a database that you provide the LLM in addition to its, let's say, foundation knowledge. Yeah, so everything here we store in a vector store. It's actually not stored in the actual LLM. The LLM is untouched. Yeah.
So we have a lot of information. Like suppose if I am going to a doctor and I am telling her some symptoms. So, but doctor sees.
I'm not sure if anyone can hear you, Mohit.
Hello. Yeah.
I think you need to be super close.
Yeah. Sorry. So, like if I am going to a doctor. So doctor, I tell 4 or 5 symptoms to doctor, but doctor sees my face, he realizes, okay, his eyes are yellow, or face skin is something pale. So those things will not be fed, and then the analysis which comes from these vectors may not.
Yeah. You are totally right. This is why this is an assistant system. And what's super important is for any LLM is you need to provide as much context information as possible. And this is not to replace doctors. Yeah, it's an assistant tool to assist doctors. Yeah, and I think in the future, when the LLM also basically can see, yeah, it actually can listen to what you're doing, and that's what OpenAI is currently doing. Yeah, this new GPT-4 O for Omni. So Omni basically being able to be multiple modalities. So it sees, it speaks, it hears. Yeah, and if you then take all these inputs, then the medical doctor will be even better than if he's just having the information from your query.
So, like these vectors are like, because in our human brains, we store the information in neurons. And with more knowledge coming into that, our neuron cells increase. So here in this case, our AI, so like we had given them the 10 pages. So will they make combinations, different combinations, and try to?
No. This is what we, so basically it is two different concepts. First of all, we have trained the network, which means it's somewhat fixed, because that's where we are today. Yeah, we train the model, and after that we have all these weights or parameters, and they are just fixed. Yeah, and then if we want to provide additional information, we take a workaround with basically adding a vector store on top of that. Yeah, so that's the way we basically bridge the challenge that the parameter set is static.
But can we do like make it self-educative, because if it is going to 20 sites?
In the future, I'm pretty sure that will happen, but we're not there yet. Luckily, once we have self-improving AI, that can get really scary.
Okay, thank you.
Okay.
Thanks for the interaction. It was nice.
Good,
it was
thanks.
Nice.
Okay, so that's the end of part one. Do we have questions? And I know no one wants to ask questions because maybe they think the question is not good, but please, that's a chance to ask questions.
How do you protect data which is being sent to LLMs?
Yeah, so that's a very good question. So basically, OpenAI is like a vacuum cleaner for data, because they need data. That's also the reason why suddenly ChatGPT is free, because they want more data. So of course we cannot use it in an enterprise context if basically OpenAI takes our intellectual property and trains their own model with it. That's why you actually need then to move to models which are basically hosted in a way that are enterprise ready. And there is, in the Azure cloud, you have the Azure OpenAI services. And if you use these models, then Microsoft guarantees that your intellectual property and your data will not be used to train the model. Yeah, and if you want to use this in any enterprise-grade setting, you actually need to go either to AWS Bedrock, there you get the Anthropic models, or you need to go to OpenAI services with Azure, where you get the OpenAI models. Never take important information and put it in ChatGPT. Don't do it. Yeah, so there's this case from Samsung engineers who wanted to basically play around or see how they can improve their source code. They actually put that into ChatGPT, and this is how the stuff leaked. Don't do it. Yeah. If you work in a company and you have the free version of ChatGPT, never ever put any source code into that system. Don't do it. Yeah, it's basically like posting it on the internet.
Right. So do you think something like LLMs can be like run locally?
Yes.
Yeah. Okay.
Yeah. So you can actually do this, but there's like open source models. So first of all, we need to define what is like open source in LLMs. Yeah. So OpenAI or Anthropic, that is closed source, meaning you don't get the weights. Yeah. So with an open source model like Llama 3 or Llama 2, you get the weights. But that is like comparable to getting a binary. Yeah, it's still not the open source as you would imagine open source, because they don't give you the tools to build the model yourself. They give you the weights, which is basically the matrix or the tensor we looked at, the weight matrix, And then you can basically use that and use it for fine-tuning, or you run it on your local device. This can be done, but you always need to consider the computational load that it needs. Yeah, so you can take like a Llama 3 billion parameter model and you run that on your MacBook. Yeah, once you get to 80 billion parameters, it gets really slow. You will need, let's say, like 96 gigabyte of memory, then it works. So can it be done? Yes. And it always depends on the use case, yeah? So if you have, let's say, a relatively simple use case where you just want to summarize text, you don't need to use the Ferrari, yeah, if you go to the grocery store. Yeah, like, so you don't need to use OpenAI for that. You can actually use a way smaller model. Yeah, and that's why it's super important to always look at what's your use case, yeah, and then do some research, what is like the most efficient way to implement that. Yeah, and the most expensive way is always to use Claude or OpenAI for everything, but it's also super smart to look into smaller models and then compare. What is the result you're getting here? What's the result you're getting there? Is it good enough? And then I would always go with the local model.
Makes sense.
Yeah, and
Makes
if
sense.
you want to run it locally, it's like Olama, for instance. Yeah, that's like you can install that. I also have it installed on my MacBook, and then you can run smaller models. I recommend not larger than 8 billion parameters, or if you have larger ones, get a larger MacBook, but it will be super expensive.
Okay, makes sense. You also showed us the tool where you have given it to the doctors and stuff,
Yes.
right? As a team, how do you make sure that this tool doesn't reach a patient and then they do the diagnosis on their own? The reason being, in India, or at least in all the developing countries, you get all the medicines out of the counters, right? You don't have to go to the doctors. Like, how do you make sure as a society, like, how do you like restrict? I know it's all educative and stuff, but don't you think this is like overboard?
Yeah, well, anything can leak. Yeah, but this is like an application only made available to the doctors. Yeah, in theory, yeah, and it has a login. Yeah, but in theory, if someone shares the login, then anyone could basically use it. Not a good idea. Yeah, especially not with the medications that are used in intensive care.
Absolutely.
And luckily, you will not get them. So.
All right.
Yeah, but if you look at antibiotics, yeah, but I would not recommend starting your own antibiotics therapy without consulting with a real physician. Yeah.
Thanks. Thank you. Yeah.
Any more questions here, please?
So continuing with the same question, like what will be the accuracy of the data which is shared?
It depends. Initially, you might start with 80%, and then you will need to go through feedback loops to get this like to higher than 90%. And the reason is that sometimes you find that your chunking strategy was not ideal for certain questions, or you also find that there's also errors in the source content. Yeah, so all these documents are not bug-free. Yeah, and if wrong information is in the source content, then your answers also will basically be wrong. So then you need to do debugging, yeah, to basically see which chunks were used. So it's like a step-by-step debug that you need to do to then identify, is the problem actually in the source content that you used? Is it in the chunking that you applied? Yeah. Is it in the prompting that you used? Is it in the language model that you used? So there's like many dimensions of what can go wrong.
Here I have the mic. So with respect to the chunking strategy, what is the strategy that you used?
Yeah, so we're actually getting into chunking strategy right after my session here, where Maha and Farook will talk in detail about how the chunking actually works. But for such a document like what we have looked at, it gets kind of complicated.
Okay, sounds good. And how do you measure? Do you have the ground truth, and are you using any LLM observability tools to measure what the retrieval, how it's being retrieving, how it is being?
Yes, so you basically, that is super important. You basically need to monitor what's going on. You also need a certain amount of supervision. And it's a little bit comparable to if you would monitor a human. I always try to think about the language model being a human. Well, it's not human, but the way you need to work with it as if it was human. Yeah, so basically, you need to monitor it, you need to supervise it, you need to basically look at what it's doing. Yeah, so all of this needs to be done. Like with an employee, you need to do regular reviews. You need to provide feedback. Yeah, and even feedback then can go into like an in-context learning loop to improve future responses. Yeah, and I think that is like all key elements where most people are just starting to grasp what kind of effort is actually behind running this kind of systems. Yeah, to make sure they really provide quality responses and not accidentally do things wrong. I think what's always super important to understand is humans make errors. Yeah, human doctors make errors. Yeah, the assistant also makes errors. That's why this basically chain of thought, yeah, the reasoning, illustrating this is super important. How did the system conclude to the answer? Because that then allows a human to understand if there is some logic problem in the answer. Yeah, what is really problematic is the point in time when people tried it and it suddenly don't look anymore what it's doing and just blindly take the result. That is like a little bit the scary thing. But humans make error, LLMs make error. Yeah, you can only try to minimize this. But everyone always expects from a technical system to be perfect. But that is not the case. Yeah, and it will not be the case for a very, very long time. Because there's sometimes also misunderstandings. Oh, I misunderstood your question. I assumed you meant the following. The same actually happens with that system. Yeah? And that's where we need to be somewhat careful in how we actually use this in, let's say, mission-critical workflows. Yeah, if it's a simple workflow where nothing is at risk, just let it do its thing, continuously monitor what it's doing. Yeah, if things go wrong, not a problem. Yeah, but as soon as you get like into a critical use case, there you really need to have everything in place, and very similar to what you would do with employees. How do you basically supervise them? How do you provide feedback? How do you do quality assurance? Yeah, do supervision? All of this applies also to these systems.
On the same note, so the providers are already providing certain guardrails, right? And in specific, because you are in a health industry, how are you ensuring those guardrails apart from what the OpenAI or any Gemini provide?
Yeah, so what you always need to do is that you, of course, you need guardrails, full stop. But you also need, let's say, somewhat friendly users. Yeah, it's way different between putting something to the public, like B2C, or if you have an internal use case. In an internal use case, users normally don't try to take advantage or trick the system. Yeah, in a B2C use case, everyone will try to get stuff for free. Yeah, so we will have lots of people trying to break your system. Yeah, which is actually frequently happening. Yeah, where there was this example, this Australian supermarket chain, they basically wanted to provide like recipes based on what's the content in your fridge. And then people just were putting stuff in like cleaners, yeah? And then suddenly it started to create really toxic recipes, and that's of course what you need to prevent. That's why the best practice is, usually you need like a kind of self-reflection framework. And with self-reflection, I mean is before the LLM responds, it actually sends this to a second dialogue, yeah, where also an LLM is going to assess the answer against certain parameters. Yeah, it's called self-refine. Yeah, so there's lots of research out there. And that actually helps you a lot to prevent this completely catastrophic failures. Yeah, so basically, the one LLM is basically having the dialogue with the user, but before it responds, it sends the response to a second chat, and that chat has the task to assess the response along various dimensions. And if it concludes that this is a not appropriate answer, it will basically send that response back to the original chat that should respond, and it will then basically reconsider or tell the user, that this is not appropriate and we're not going to do it. So that's called self-refine or self-reflection. And that's basically how you can get to more sophisticated systems which try to put in more guardrails, so that the users or that the answers are not completely wrong. Any more questions? Anyone in the back?
Yeah, this one.
Yeah.
So
please.
you are mentioned that LLM model have the hallucinations. Sometimes we are giving the prompt, same prompt, the response will be different every time.
Yes.
So how will we avoid it in the retrieving the documents or something text?
Yeah, so basically hallucination occurs when the LLM is having not enough context. Yeah, so the more vague your question, then it will just start to make up stuff. And this retrieval augmentation generation, that's actually a great way to provide a lot of context. And the more context you provide, the more unlikely it is that it will just hallucinate. Yeah, I think that's important. Yeah, and then especially if you have ChatGPT, depending on how you ask the question, the response might differ greatly. And the reason is that ChatGPT is not just one model that we looked at. It's actually a mixture of experts model. So it's basically 8 different models glued together. Yeah, and depending on how you phrase the question, you actually will activate different of these expert models. Yeah, and usually it activates 2 of them, then looks at the result, and then you basically get the one that it feels fits best. And that's why sometimes, depending on how you phrase something, you get a completely different response. And that is because you ended up in like a different submodel which is providing the response. Yeah, if you, for instance, work with Anthropic, with Claude Opus, that is just one model, no mixture of experts. So it's never happening there. Yeah, that's why I personally just use Claude for whatever I do, because that's like not erratic and it just works better for my use cases. Yeah, but mixture of experts actually has the challenge that depending on the question you might be, or how you phrase it, you get maybe deviated to a different expert. And they do that to reduce the computation. Yeah, so that's why they have specialized submodels. Yeah, which is good and bad at the same time. Did that answer your question?
Yes, sir.
Okay.
And one more thing, how do you choose the embedding models? Because we are using the medical based kind of document retrieval, so we need an embedding model. Which model you are used preferred? Because they need to making a vector DB giving the result of better way. So which embedding models will be preferred from the OpenAI or something else?
No, this
not
is
from the cost efficient, from the users who are maybe students or maybe other thing they want to try it. So in that case, which kind of embedding models will be preferred for to getting the good results?
Yeah, so it actually depends on the use case, to be honest.
Okay.
In the medical case, you cannot really use OpenAI because it's very hesitant to answer any medical questions. In this case here, it's actually Claude 3 Opus. That's the only model that can do this. There's then also more specialized models for medical use cases like Meditron. That's like a fine-tuned Llama 3 model, Meditron. Yeah, and my recommendation is always, for a particular use case, try different models and see which actually gives you the best result. And you always also need to look at the cost. Yeah, so 1 million tokens of Claude cost you $15. That's kind of expensive. Yeah, so you only want to use that if it really makes sense. And context means always try to give it the absolute minimum information that leads to a good result, because that then reduces your cost significantly.
Is it possible we can able to fine-tune the model from the RAG system?
Yes, well, you can fine-tune models, but not all models. Yeah, so GPT 3.5, for instance, you can fine-tune. GPT-4, not at this point. Yeah, and what you basically do is, with fine-tuning, you need to create a data set with question answers, a lot of them, and then you basically fine-tune the model on your specific use case. Yeah, and if you want to fine-tune models, I would recommend please start with like Llama. That's the easiest. Yeah, if you want to experiment, take a small llama model, like 8 billion parameters, and try that on your MacBook. That actually works. Yeah, and what you can also try is when you have a data set like that you otherwise would use in retrieval augmentation generation, you can ask like a stronger model like Claude or OpenAI to help you to create a synthetic data set. Yeah, so basically question answers from your text, and that you then use basically as the input for your fine-tuning. Yeah, so that is the alternative. Yeah, if you don't do retrieval augmentation generation, then fine-tuning is your next best option, but that's also more complicated. Yeah, so that's why most people actually stick with doing it with RAG, especially when you have like huge amounts of content. Then fine-tuning the model might not be really feasible.
Okay, thank you.
Okay. Any more questions? So
Yeah, I have one question. Oliver here.
Okay, all the way. Didn't see.
So how are the quantum computers gonna change AI?
The quantum, yeah. Oh, that's a super interesting question. How is quantum computing going to change all of this? I would say at this point, I'm not exactly sure, but what you can actually do is, and there is a few people already trying to build like analog ways, yeah, to basically work with these kind of ML models. Yeah, people actually try to create optical elements that actually can do very, very complex computations in absolutely fast. Yeah, and maybe eventually when the quantum computers actually have more active quantums, yeah, then probably they can also start solving these LLM type questions. Because in theory, I think it's a big alignment between how the quantum computer works, yeah, and if we want to get the LLM more efficient. Yeah, because at the end of the day, what we have is we have like a big net of neurons. Yeah, and if we imagine that we basically in the quantum world can replace this with like waves, yeah, then there's probably a huge opportunity, but we are probably a decade away from making this work. But this is like highly speculative at this point. but I have been thinking about that question for myself also, but I would say at this point quantum computers are not far enough, but they're making really great advances. Yeah. Any more questions? Okay, then I guess if you have any more questions, then there will be another Q&A session later. Then thank you so much and hope you enjoyed my talk. Yes.
Hello. Thank you so much, Oliver, for the insightful session. People, like, if you have questions, we can have at the end, like after the second session. Meanwhile, like, we have a short icebreaker. So it is called an escape room. To this, you can group yourselves into 3 people. So it can be like 3 people in a group. So how it goes, like, we have a timer of around 15 minutes, and you'll be having 3 levels of questions that is related to AI. So each question you answer will make you to move to the next level. So if you, in case you answer a wrong question, wrong option, it will be redirected to the same question, and it should be like, it should be prevailing until you give the correct answer. Okay, it is like 3 level. QR code will be displayed here, and we have volunteers to monitor you. So whichever group have completed first in the 15 minutes of time will be considered as the winner. You can group 3 people in a team. Yeah. Shanti, please do take care of volunteering. You just scan, and please do wait.
Everybody has opened. If they completed, ask them to stand. அவ்வளவுதான், வேற வழி இல்லை. அங்க பாரு, எல்லாரும் ஓபன் பண்ணிட்டாங்க. ஃபார்ம் பண்ணலாம், ஆனா அங்க பாரு, எல்லாரும் ஓபன் பண்ணிட்டாங்க போன். நீ என்ன நினைக்கிற?
Please do wait until I say. Please. I just want a confirmation, like, are you guys formed in a team?
Yeah, guys, please wait. So just form the team now, and we'll say, then you start, okay? Just form the team now and be ready.
Yeah, volunteers, please take responsibility of each row and give a heads up so that we could start. So it's basically an AI-based question. You could use Google to search or whatever. So the thing is, like, it will make you to move to the next level when you give the right answer. So when you complete the whole set of questions, please do inform to the volunteers so that they'll make a note that you are completed. Surya, timer edavadhu display panna mudiyuma? 15 minutes. Over question maximum retry illa kediyadhu. Actually, adu escape room maari Farook. Nee correct answer panna it will go to the next level avladhaan. Tappa kudutha thirupi adu varum, neenga thirupi kudutha next level. Team will display the QR code. Please do scan and wait, and we can kickstart the escape room game. Yeah, 3 in a team. Please do scan, and to have a better experience, please keep your phone in the landscape mode so that you could use it better. Sorry. Volunteers, like, can we start? Okay. So it will be like a team. It depends, like, each of your team members can or use one mobile for game, one for game and another use for Googling. So it's up to you guys. So the basic rule is that only when you give the correct answer, it will take you to the next question. So unless you give the correct answer, you will be redirected to the same question. Is it clear? Like, anyone having any doubts? So volunteers, please have an eye. And the team members, whoever completed, please inform to the volunteers so that they could make a note of the time when you have completed. Yeah, you can start, guys. Yeah.
If your team hasn't started already, please
Okay.
volunteers make use of the timer?
Volunteers, if the team that you're looking haven't started yet and it's starting late, please do have a timer for yourself, because the timer that we display have started already. So if your team haven't started yet, please do have your own timer and make a note, please. Team whoever completed first, please approach your next volunteer. I think, guys, you can make use of this opportunity to learn new concepts, I guess, so that read the question and then try to answer, not just click the answers randomly. Yeah. Volunteers, please take a look on the timer and keep in track. If any team have completed in prior, please do inform the volunteer next to you. Have completed. Please inform the volunteer next to you. Teams whoever had completed, please contact the volunteers next to you so that they would make a time. They would take a note on the time when you have completed. Okay. இதுக்கப்புறம் ஒரு 10 minutes break தானே சொல்லிருந்தோம்.
10 minutes சொல்லிடுங்க. வரதுக்கு minutes ஆயிடும்.
ஆனா முடிக்கிட்டு எல்லாரும் முடிக்கிட்டு சொல்ல வேண்டாம். Volunteers, please do only make a note of the time and don't reveal the team like whoever completed. Once everyone completed, we can have the stats like who completed and we'll see the winners. Volunteers, please note the time and any one of the team members so that we could call them and say. Sorry? Volunteers, the timer is going here on the screen. Please do make a note. ஃபஸ்ட்டு 3 தான் யோசிச்சிருக்கு. ஆமாம் ஆமாம். Shanti, can you coordinate with the volunteers and get the list alone? Team, I request everyone to encourage the people who won. Thank you, team. And the second team to complete the escape connect is Tarun, Ritik, and Sri Hari. Yeah, how was the game, guys? Like, seems you completed too early, right?
Actually, it was like quite interesting. And for some questions, it was like even if you got the answer wrong, like we had the option to redo it, so it was actually easier.
Thank you. And the third team to complete the escape room earlier is Jayapandi, Akash, and Akhileshwaran. Thank you so much, Oliver. So before kickstarting into the second session, we'll have a small break. Refreshments are available at pantry. Meanwhile, you can meet Oliver, and HR desk is also available outside for networking. Please use the time, and we'll get back by 3:50.
also into mentoring resources wherever he goes. So without any further delay, I'll hand over to Maha to start the demonstration along with his team. Go to Maha.
Hello everyone. Yeah, let's wait for some of them to get seated first.
Guys, even if you have snacks, please have it at your place. Volunteers, please make people settle.
Lighting, okay.
I think we can get started, Maha. Yes.
Yeah. So first of all, thank you everyone for being here, and really it was an awesome session by Oliver. Now, actually I am thinking what to cover. So after such a wonderful session by Oliver, almost Oliver covered end-to-end in AI. Yeah, we are thinking now. But don't worry, we have very something interesting for you to cover up here. In this session, me and my team will be talking about how to build a RAG chatbot by applying some advanced technologies as well as some good practice. So I like to introduce my team as well. Farook, our senior AI engineer, Kumaran, our AI engineer, and Bala, our technical project manager. So they are beyond this task. So I really want to thank them as well. So let's get started. So in this session, so we will be covering about importance of data analysis. So why data analysis is important? So before we build any data products or LLM models, why data analysis is important? Followed by data pre-processing, data chunking, embedding and indexing, as well as prompting, advanced prompting plus building RAG. So we will be covering this session along walking through our code. So now, before we are diving into this session, I like to understand what made Gen AI so popular. So can anyone answer? May I have answer from you people? So what made Gen AI so popular?
One reason I see is that OpenAI gave it as free access for 3.5. That's one of the main reasons that it got popular.
Yeah, so that is the one of the reason. So actually, many people, especially non-technical people, always believe, ChatGPT and Gen AI are same. So whenever we talk about Gen AI, they say yeah, I worked in ChatGPT. So because it is free. So that is why it is able to reach a very big audience in short time. So I say, as Oliver mentioned, in 2 months, billions of users. So really thank you. So that is not the only answer, but. So is there any other guess? Yes.
Well, actually, in generative AI, we get response in text format. Let's say I Google something. I'll be getting a bunch of links, not the exact answer I'm looking for. But in generative AI, I'll be getting the exact answer I'm looking for.
Yeah, somehow closer. So let me tell you the difference between. Is there anyone? Yeah. Yes.
Maybe less thinking and less usage of our brain.
Nice try. Yeah, maybe. Yeah, but let me conclude this. So the most important thing is so before LLM or Gen AI, what we were using. So we were just reusing the data exists. We keep using the same data and we try to create something. But after Gen AI and LLM, so it brought some more creativity. Everyone who are using, even technical person or non-technical person, that sounds more interesting for them to go and create their own content. They can create the text, they can create image, video, even at home. You can see some of our children using ChatGPT. So to create the video, images, everything. And one more interesting factor is synthetic data. Is there any clue what is synthetic data is? Yeah, it's generating data. Yeah, I will give you Some clue? What is synthetic data?
Yeah, it's just a
Artificial data. Yeah. So this is regarding synthetic data. So synthetic data is something like artificially generated, but in reality it looks like a real data. So that is where like hallucination also created. So sometimes like the vision also may deceive us, like it look like same, but it is not a reality. So that is why, right, Gen AI also became so popular. So it helps us to create, imagine and innovate many things. Then, so if Gen AI is so great, so what is the challenging in using generative AI? Yeah. 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 So actually the answer was provided by Oliver in the previous session. So the first thing is hallucination. So that is the biggest challenge. Like anyone who uses Gen AI, hallucination is the biggest challenge. So hallucination is also a biggest threat. Like when you see any model built with some hallucination, so what happens? It creates loss of trust. So first thing is like loss of confidence. So if any product, any LLM model is giving you wrong answer or wrong response, we may not use it, right? So that is the reason hallucination is a biggest threat to our LLM model, right? So then, how we can avoid hallucination? So like when talk about the hallucination, I also want to cover few areas in like types of hallucination. So we are heard many times like hallucinations in many places. So here, types of hallucination, just see. So hallucination can be because of fact, when the response is completely different from the fact. So one example you can see, right, I am asking my LLM model, yeah, narrate me a story of a cow. It says like there was a cow in a pink color, which is totally against the fact. So there is no cow in pink color. So that deals with the fact. The next comes the input, right? So it is something similar, like I ask my son to buy sugar. So he comes with the salt. It is totally different from what I input and what I get. So that is what like I input relevant hallucination. And context. So this is very important use case because most of the LLM model, like they become popular because of the conversation. So we conversate in ChatGPT. In context, what happens is, right, we start with one conversation, but at the end of the conversation, it is completely different than what we start. Say example, the same example you can see, right? So in the initial stage of conversation, I say I like hamburger, but at the end, the ChatGPT or any LLM model what I built, it understands I don't like hamburger. Maybe I like pizza, something. So there is no consistency. So these are the three types of hallucination that every model, like every LLM model or whatever we are building, we may come across. Yeah. Right. So then how to minimize the hallucination? So these are the tactics, like build high quality data sets. So how to build high quality data sets, we can cover in later. Apply based chunking process. So one of the area, like instead of like chunking page wise or size wise, it is always chunk data by context wise. Say example, like your section starts in page 2 and it continues till page 4. It's better like you chunk by section wise, so that we don't lose context. So that is one of the best practice. And then advanced prompting. So yeah, when we start with ChatGPT, like we just give like give me so and so. We never followed any format or anything. Exactly, right? So, but now there is like advanced prompting which we need to exercise. We need to use it predominantly. So then RAG, building a RAG system. So that will help you to avoid hallucination because it always relates context. Then fine tuning, and one more advanced tech stack is like in context learning. So these are the 5 areas. When we concentrate more, we can avoid hallucination. Yes. Then building high quality data sets. So mostly like how many are here from data background? Data engineers or someone? Yeah, only few. Like they might understand this very well. So understand the data we handle. It is not like there are process tales like we collect all data, we collect as many data, it means we can produce good result. That is the belief. Collect all data, we can produce good result. And there are also like some cases when we meet with some issue. When you are running a pipeline or design your data model, when you come with the issue, we ignore some small part of the data. So never ignore like that. So even a small piece of data is very important. Do data analysis, right? So I will give you one example of data analysis. Take this. So how many people have used Jupyter Notebook? Yeah. So if you have used Jupyter Notebook, this is simple script like userdf is null.sum. So this command help you to know how many null values are there in your data set. A simple instruction I gave to my engineer, that is by fault, I gave to my engineer when he built LLM model, ignore the column which are null, too much nulls. So take this example. So in this example, we have around 3,40,000 rows. And if you see, like I highlighted is subscriber, that has non-null value is 20,000, which is like very less than 10% of the actual records. So I instructed my engineers, so when you build a LLM model, do exploratory analysis, ignore the data, which are too many nulls are there, they are meaningless. So that is my mistake. Yeah, he is a dedicated employee, he just followed my rule. So at last, what happened is, this is subscriber, one of the main key column is been ignored. So actually, like the goal of this model is to get some analytics, like how many active subscribers are there. So this is the key column which can give you. So actually, like here is where our analysis plays important role. So what we need to do is like simply convert this subscriber as I mentioned. So either it is to be one, whenever it is one, make it active, and when it is null, make it not active. So that makes sense. So that is why like don't ignore any columns or any field because it doesn't have any data. Go and do some analysis. Why there is no data? What the small piece of data available has impact in the data system. So that is the one example. And the second thing, like this is a real-time example I just want to showcase. So this is a very good example of data analytics. Probably many would have seen, if are few those who have not come across. So this happened during World War II. So World War II, there are many like US Army used fighter aircraft. After bombing like opposition parties, like they returned. Unfortunately, some of the air fighters didn't return. So US Army want to do some analytics, like they want to know why they didn't return and how they can protect their aircraft. So as a result, all these engineers discussed and come up with this cluster analysis. They investigated all those flights returned, and they say like all those areas in the red dotted bullets like cluster, those are the areas like where the aircraft takes lot of bullets. So they need to armor those areas very well, protect those areas with more shield. So this is the conclusion brought by the engineers. As usual, right, anything that need to be go to the next stage, we need to take some approval. So this goes to approval. So there is some lazy guy, like always architect like me. So they'll sit on there. So it goes to approval, and in simple term, as like the approval said, yeah, instead of like just concentrating on the red cluster, the protected area should be on the blue, like those areas marked in blue. Anyone guess why it is? Actually, this is a real scenario, the real strategy done by US Army. Yes, exactly. Yeah. So because you deserve this. Because the analysis done is to protect the flight. So actually those flights which took the bullets on those areas have not returned. So that is the area where the more protection need to be covered, right? That is why like depth analysis is required. So whatever data you are handling, do a depth analysis. Sometimes visions may like deceive you. So do some depth analysis. Yes. So this is a live time for demo. So like Oliver has covered lot of things. So let's directly jump into the demo. This is a simple architecture. So we are using PDF file for unstructured data, and then document AI. So document AI is one of the service, one of the service available in Google Cloud Platform. And Llama Index, again Llama Index like framework, LLM framework. So we use this one for this live demo. Let me, so just a few points on the Llama Index. So those who are very new, so people like still, although we are very new to AI model and AI things, people still find difficulty to difference between LLM framework and LLM model. So if I talk about LLM framework, so Llama Index is one of the LLM framework. So other framework are listed here, like Chennai, Gradio, or the other framework. And when it comes to LLM model, we have OpenAI, Cloud Anthropic, Mistral, Gemini, or those are LLM models. So we need to find difference between these two. Because generally when I talk to some people, when I ask like what they are working on, they say like we are working on building LLM model. So what model they are in, they get confused. They say like they are using Llama Index, they built everything in Llama Index. What model? They are unable to explain this. So just understand this. And again, Document AI is another service available in Google Cloud Platform. Right. We have taken unstructured data for this live demo. So the reason is most of the company, almost all the companies are having this data. So in form of PDF or JSON, in many format. The real challenge is right when the data is unstructured. So we might have worked with a lot of structured data, just directly connecting to database, relational database, query the data, get the data what we want. But it is really challenge when we deal with unstructured data. That's why we have just taken a PDF file to demonstrate here. Let me go dive into the coding part. Yes. So for this demo, we will be using this PDF file. So why we chosen this PDF file? So this PDF file contains image as well as table, a workflow diagram, and rest are the contents. So we are trying to cover all parts like in one demo. So that's the reason we chosen this PDF file. Then going back to Document AI. So let me give you an overview of how this Document AI works. So in order to use Document AI, you have to subscribe for a Google account. So now like you are, for a free tier, you have a 300 credits. You can start using it. And when you first start with Document AI, you have to enable Document AI API. So that is the first thing you have to do. So this is called Document AI. So if you just log into Google Console, you can see how the Document AI, like you can simply type Document AI, you will land it here. So the first step what you need to do is you need to create a processor. In Document AI, you need to create a processor. How you will do it is just go to processor gallery. You can see document OCR, form parser, layout parser. Here we have used document processor, OCR. So I have already created a OCR processor. So what is important in OCR processor is take note of the OCR ID. This is the OCR ID and followed by the endpoint plus region. So these three are very important so that like you programmatically connect to Document AI by using Python or any other things. How it works. So just give you one example how this works. I am taking the same anatomy file, takes few minutes to load. Yes, you could see it is loaded. As soon as it loaded, you can see it, right? So every text, OCR capture every text. And in page 2, you could also see in image. So in image, you can see the text, the insert labels, they also been captured. So that is the power of OCR. And inside the workflow. So inside the workflow, you could see each and every text has been captured. So this is the reason we used the Document AI for this purpose. I will also walk through some of the coding part using Jupyter Notebook. So before that, I want to show you, this is a cloud storage where you can dump all the PDF files or any form of the files, you can store it in the cloud storage. For this example, in input, we are storing the medical anatomy PDF file, and I'm going to show you how this is going to get processed. Yeah. So step one. So step one is like importing all relevant libraries. So basic libraries. So still we are using Llama Index. I'm importing Llama Index basic libraries. Some of the important libraries are like PG Store, OpenAI embeddings, Anthropic. So these are the three important libraries we are importing. Additionally, right, we have the simple directory reader. Simple directory reader is right to read all the data from all the files in a single directory. So that is why we use simple directory reader, followed by importing Google Cloud dependent libraries, because we are using Google Cloud Document AI for this demo. That's the reason, right, we are importing Google Cloud library. So let me show you. So this is the input file. In output, it is empty. So now I'm going to process my code. Let me go one by one. So we are using environment variable file where we will store all our environment variable. Example, right, if you want to use Anthropic API or Open API, so you need to save that API key in environment file. So for that is like a good practice, always storing your API keys or any confidential keys in environment variable. And then embedding model. So for this part, we are using OpenAI embedding model. To embed the collected data, we are using OpenAI embed model. And for LLM model, we are using Anthropic Cloud. So let me process one by one. So this step, so what this step does is, right, it read all the data, all the files in the input folder, convert that into JSON, like extracting all the text from the input file, and then save it in the output folder using Document API. So I'm going to process it now. So it is on the way. It will take few minutes. So by the way, it is running. I would like to show you how the vectors embeddings are stored in the database. You can see, so here we are using PostgreSQL for storing our vector, and this is how the output looks like. So PG vector store the output as like a metadata. Metadata is a place where you can see from which file data has been extracted and what is the type of the format of the file, and all those information is collected in the metadata. And embedding, so the entire texts are like converted into embedding and saved in the numeric format. So this is like how the real embedding look like in the PG store. Then going back, so now the process is completed. I am going into my output folder. You can see a new set of folder is created, and here is the JSON file. So what happened is, actually all data has been extracted from the PDF, and that has been saved as a JSON file in the cloud storage. Let's have a look how this JSON file look like. So so the beauty of this document is, right, you will get two type of output. One is the complete PDF file is converted into bytes. It saves the complete structure of the PDF file and provide you as a bytes, and also it extract complete content and give you as a text. I will show you. So if I just type content, you can see the bytes. It means, right, the complete total PDF file is converted into bytes. If you run these bytes, if you're using PIL image library, you can see the complete PDF file. Similarly, for the text, you can see this. The entire PDF is being explored. All data from the PDF is extracted and collected here. So the anatomy of the somatosynary system. So this is what you have, the first page. First page followed by from Wikibooks. You could see it here. From Wikibooks. So almost all data is collected. So the one good thing you can see from document A is it also provides you confidence score. Confidence score as well as the coordinates where each data lies. So in future you can use this if you want to particularly extract some content in particular coordinates. So this is the place. So any doubt here till now? Pardon? Image get transformed. So let me open a separate code. Yeah. So let us cover it in next bit. Like I will share you. But you can see the entire image. So that is available in Jupyter Notebook. We can share you the code to run it. The entire PDF will be available as an image.
Can I raise? The text extraction from the PDF is fine, but I have a query. If my document is a 2-column based document, the extraction is from left to right. I'm right, mostly line by line, reading extraction will be happens on it.
Yeah.
Suppose if my data will be the 2-column based pages mean, first column paragraph will be have the continuous in manner, that means meaningful. So after the extraction from the PDF, while I convert it into the chunking, my meaning list, that means the content formation will be differ. The meaning of the that means chunking will be maybe differs, right? How we will overcome this kind of problem?
Not exactly. So there are two things you can do. So one is, right, if your PDF file is too big, assume like what we have taken here is small part. So if your PDF file is too big, you can apply some best chunking practice, like either by sentence wise or like page wise. So particularly like chunk by section wise. So that will help you more.
That is not the I have only a single page of PDF, but PDF page is 2-column is there. That means paragraph by paragraph, so 2-column based, that means page is split into 2 columns. While we apply the OCR blindly, mean it will be line by line read extraction will be happens. For example, first column I have some continuity will be appears on the second column on same pages from the top to bottom approach. If I go with the OCR, it will be read from the left to right from entire the line. That means first line. It's never understand is a column 1 or column 2. It's just a single page. It will be first line will be entirely readed. So that time my meaning of the data will be changes. Even though I go with the chunking apply, that means over chunking, whatever it may be I do it, but meaning of the data will be changes. How it will be overcome it? Because in this PDF also I can able to identify that column is there, 2-column based pages is there. How it will be read and the model, how it will be understand on. Because when I go with the vectorization, the entirely part will be maybe the wrong predictions happens on the OCR extraction is fine. But after that, how we are going to handle the raw data? That is the problem.
Raw data means, can you elaborate more?
Can you show the PDF page?
I could understand, like 2 columns we have.
Yes.
Yes.
That means 2-column basis paragraph is there.
Yes. So let me walk through the actual text it has got it. Okay. So we can take some part of, probably like we can also continue this discussion after this in order to understand more on the OCR. But the thing is, right, it is able to capture the complete text. So whenever the PDF file is too big, so this document AI will not work when you pass it completely. So we need to chunk into small PDF file, or like the good practice is you chunk it by as a MD markdown. So if your file is too big, convert it to markdown and chunk it into small pieces. So that will give you, like, you will not be missing any piece of the data. So that is the one practice we already implemented and found it that is useful. So we can talk more about it in after this session. We can discuss more on this, right? Yeah. So now I will show you. One more thing. So after retrieving data from the PDF file, what will happen? So how we can convert this data into building an LLM model. So that is what we're going to cover it right now. So this is a code. So what happens here is we have just integrated all the functions here, like simply like read PDF and then applying document AI. We are applying this embedding as well as storing the embedded vector store into Postgres database. So let me try run this one. So this is the code. You can see it here. So this is getting processed. Yes. We need to clear it. So I just restarting the kernel. So let's go from here. So I have restarted the kernel and it is processing. Yeah. So now vector is created. So since vector is created, now we are good to go with some prompt text type, right? So this is a simple system prompt. So this is a simple prompt like provide the appropriate response for the user prompt. So just evaluating whether my model is working. So it's a dog chat. I have not processed. Yes. So it is processing. Wait a moment. Yeah. You can see now the system prompt has returned me some output. It means, right, my model is working fine. So what is next? So you might have come across, right, whenever we work with some prompting, we create some simple prompt, and also we may expect the output in different format. In like some places, right, we may need to refer the actual content, right, refer images, refer section whenever you create any content. So how you can achieve that? So some of the best practices, right, there are two types of prompt, like we say like system prompt and user prompt. So system prompt is something like you instruct LLM model. So when at the beginning you instruct LLM model how to come up with the output. So that is what like a system model. And user prompt is something like we as a user, we feed into the system. I need a output in such a format. Whereas the system format is predefined to the LLM model. So say example, you want to restrict the content only for the kids. So you can, at the first level, you can give to system prompt. Yeah, so just filter the content. It is purely based for the kids, like avoid adult content. So something like you can predefine in the system prompt before going for the user prompt. So that is the few difference between system prompt and the user prompt. And let's go one by one on the principles. Like I have seen many of them when interacting with ChatGPT or anything, right? LLM model, they use word like please, could you. So those are the sentences like they used to give. Please give me, say, definition of palindrome. So this is quite example. That is not required. So keep your prompt very simple. So here you can see, right? Just avoid some phrases like please, thank you, could you, so nice, and be specific. Give a direct instruction to your system because it is a system. It is like a machine. You treat it like a machine and give a command to do the purpose. That is what I have given here, like define cutaneous receptor and its function. So as soon as I give this, it gives me the result. So no need to use some phrases like please and other fillers. And then target the audience. Understand your audience. Tell to the system for whom you are generating the content is for. So here I used explain to me like I am 12 years boys. Define cutaneous receptor and its function. I have used same prompt. This is a general prompt. And in second place I have put give the output for 12 years boys. You can see the difference in the content generated. It is not so detailed and it is little clear that any 12-year boy can understand. So that is one of the best practice. Then tell to the system like what is its task and what it must give you. So tell it very concretely by using your task, you must, such a thing. So this is one example. You could see your task is to explain about receptors and you must use some example from figure 1. This is like a direct thing I am just commanding to my system and it also does. So you could see the data are collected from figure 1 and it quotes it in the response. The fourth one is like chain of thought. So whenever there is some procedure involved, so don't give direct prompt like give me so on thing. So instruct the machine, tell it, give me response step by step. So this is one thing, you can see it here. Explain feedback loops for proprietary signals for the perceptron and control of lip movements. So this is a simple prompt. So when I give this simple prompt, I got the result in this way. But when I say in step by step, you could see the difference. So it provided the result by referring images in step by step sequence. So this is the better way. So whenever there is some procedure or step by step response required, you instruct the machine, you instruct the model to give step by step in response. Then as usual, right, if you looking for some output in certain format, quote some example. Here you can see, explain about different receptors with good listed format. I have also given example, so how the output should look like, so which is taken already taken from the content. So following this example, the LLM model also queue the response in such a way. So the same way as I told, like I want a list A followed by the receptor names and the description. Similarly, you could see the same way you got the output. And let's come to a system prompt. So in this system prompt, we can also tell, like as I told you, how the actual output look like. So whenever you blindly prompt it, the actual put will appear like this. So that is what initially we are giving instruction. So here what you consider it, whatever your response you want, you can tell always refer to a section. So if it is not blindly giving some context or content, referring this section. So I quote the section or figures, whatever it is associated to. So that is what you see it here. I have just instructed the system to provide section as well as page with some response, sample response. So this is what happened here. So when I request the system, what is joint receptors, it creates a pattern. It creates a pattern and provide the result in the same pattern. So that is the one advantage of system prompt as well. And then always give it a role. So don't give it blindly. Tell to the LLM model what it is role. So here I said helpful document assistant or medical assistant, whatever it is, be specific to the domain and give your let LLM model understand what domain it should pick up the data from. So one of the example is especially people who want to collect the data in the JSON format to use it in the further application. So they mostly people prefer JSON format. I have said provide me the output in the JSON format. You could see the output is in JSON format. So these are the some of the good practice, it is not blindly prompting or texting the LLM, but instead you can also organize your prompt with respect to the output, whatever output you looking for. So that is the some improvements which can help you to avoid hallucination. So just stick to whatever the content you need. So from this, I just hand over the session to Farook. Farook will be covering on the RAG model as well as a chunking strategy. So any questions so far? Pardon? Yes, so that is covered now. Okay. So I am handing over to Farook to continue the second part of the session.
Check. Thanks. But before getting into this, the next phase of the development, we shall also have a just walk through on the demo that we have, where we have built a chatbot using Chainlit. Chainlit is something similar to Streamlit we might have experienced with. So Kumaran will give us a walkthrough on that.
Yeah. So as we seen in the presentation, I'm going to demonstrate this entire presentation in the format of chat AI application. So as mentioned, we have built this application on top of Chainlink framework, which is very easy to build like this on a chat AI application in a few lines of code. And moreover, we have
this session. Yeah, share it.
Yeah, so my screen is visible. So we have Streamlint also, which is more familiar to build these kind of chat AI applications. The reason why we have chosen Chainlint is it is very easy to interact with other AI frameworks like Llama Index and LangChain. So, and in the backend, in the background, we have used Google's document AI parser, which passes the unstructured PDF into an structured JSON, which contains all the text from the PDF and also the metadata about the PDF. And then we are converting the entire text in that JSON into an vector store. And we are storing all those vector embeddings in a database. So now let's log into the application. And this is the application. So in order to start with this, we can just upload a file. I'm just using the same file what you have shown in the presentation. And you can see that the medical anatomy PDF is processing. And in the background, it's just uploading the file to the Google Cloud. And then it is converting, passing the entire PDF into a vector store. So now you can see that the application has been processed, and it's now you can chat with the document what you want. So I'm just giving a simple prompt. So I'm just giving explain about the receptors in the human skin. So you can see that the LLM is giving somewhat relevant answer to the prompt, and it also provides some of the reference like page and to the figures and what the figures in which page we have, all those things. So the reason is that in the system prompt we have given like you need to provide the relevant response with the references. So that's why the LLMs responded in this manner. And let's try our next prompt. So just give a brief detail about muscle spindles. And you can see that in the same format it returns. And let's look on the last prompt to explain about the feedback loops. Yeah, so this is all about the application, and so far we have seen only the text based prompting, like interacting with the text, but in the PDF we have some of the images, so we need to interact with the images also. So I think that will be covered by Farook. Farook, you can take over. Thank you. Thank you, guys.
So, I'm audible? Yeah. Thank you guys. Thank you Kumaran and Maha for just setting the environment here. Couple of questions we have got just before getting into the next implementation. So one of the questions is we will be how we can retrieve the content that is retrieved from the image. That is one of the questions. And if the page is having something like newspaper kind of indentation or something like a layout, how are we gonna extract information out of it? So I hope this demo would give you answers, all of those answers maybe to some extent. So here we have used the same PDF. Instead of performing OCR, but we have tried some other thing where we have leveraged at another library called unstructured. So unstructured is another library. We have split the content in the PDFs into different segments: text-based contents, table-based contents, and image-based contents. This is also fundamentally using OCR. On top of that, it also employs some other techniques that it can do certain partitioning of the content. Without any further ado, let us just get into the Jupyter Notebook and have a walkthrough on the code. Yeah. Yeah. Sure. On this, we have used OpenAI for both embedding as well as an LLM. You might have a question here. What is the difference between embedding and what if you use the LLM as an LLM in the RAG? So embedding model will convert the chunks or the tokens into vectors. The same OpenAI embeddings, or we have Google PaLM or a PaLM 2, something like that. We will be converting the chunks, the text, into numbers in vectors. And the LLM, where we are using here OpenAI, it will act as a generative part, where we will be extracting the response out of the vectors we have already stored after finding the cosine similarity. Here, since we have used unstructured, we will also be looking into how it is partitioning all of those data And also we have used here as a LangChain as a framework. So LangChain is yet another framework that will be giving us the functionalities to interact with the document on performing some chunking and on performing some conversion of content or text into vectors, and to hit the LLM and to get the response out of it, and parsing the response after you have retrieved from the LLM. So all of these functionalities will be taken care by LangChain here. And here, as you see, so let me just have a, yeah. And here we have used chat OpenAI as the main function, which will help us to interact with the OpenAI LLM. And we have used Chroma vector store here instead of going with PG vector store. Earlier use case we have dealt with PG vector store, which is offered by Postgres, and here we are going with Chroma, and it is stored in memory. We are not provisioning a new service here. And for the embeddings, as I told, we have gone with OpenAI embeddings. And so other things are kind of processing and output process, and also we are chaining the all of the inputs that we are feeding into the LLM. Yeah. And this function will take care of the partitioning of the content in the PDF or any unstructured formats, if I say. Here we have content as in we have images, we have this text, and we have workflows or tables or something like that. So all these are captured here. And as you see, so this partition PDF, which is offered by unstructured, will help us to extract the images in the PDF, and it will infer the table as it has, and also get the text-based content as per the token size that we have passed. And this function will get the PDF from that location, and it will chunk or partition, not chunking, but partitioning the data into different segments and put all those images in the same location. So after executing this, we can have the content. As you see, the image have been extracted or partitioned. All of those images have been put on as a separate entities. And from here, how are we extracting the information from that image? We are performing vision here. So we are going with open like GPT-4 vision. So all those image content has been summarized into text, and that text has been stored separately. So while performing any of the user query, like if a user is prompting, so at that time a function will call. A function, what it does is that will combine image as well as the text content to give the final response. And yeah. And as you see, what about the other segments? So one is image we have extracted. What about the other segments? We are categorizing it to tables and text. So all those will be, like the beauty of unstructured is here it will interpret all the content and it will segregate into elements, which in the form of table, composite elements, text, images, and formulas if you have it in your PDF or any unstructured data. All those will be segregated into like types of elements here. Here we just gone with just two type of element. One is table, and another, all those text are considered here as a composite elements. And so we are taking text as, we are assigning all those text-based content as text and table-based content as tables, and we are just summarizing all those tables into text again. So like visually we can see, as a human we can differentiate the difference between each columns or each row of the table, as a like partitioning, we are segregating it, and as well we have to get the summarization of what we have just partitioned. So for that reason, we are just summarizing all those tables, and we are putting on to an array of sentences. And this thing here, this is where we are performing vision. So we already partitioned the image, and we need to extract the text summaries. So here we are performing GPT-4 vision, and we are sending as base64 code. The image has been sent as a base64 as input. And once that is done, so we are just appending all those data into a new array called image summaries. So this will take some time, as we are just sleeping here for 10 seconds. Yeah, it is done. And as you see, we are getting these text summaries as in an array of text sentences, and table summaries as in an array of yet another text sentences, and image summaries. So everything as text. We haven't left any of the data in the PDF as of now. So all has been converted into text. And what are we doing here? In this one, since we have everything as separate entities, we just need to correlate images as well as text here. So we are just maintaining a dictionary, like our JSON object, if you're from JS background, and we are just putting the image as well as text into a single entity, and all of those will be converted into vectors and stored in ChromaDB using OpenAI embeddings. This is where we are doing it. And we are using in-memory store. So we are not going with some like local device storage. And all those functionalities will be covered here, and with the dog store and ID key as well. And this is where we are writing the main prompting function. And here these functionalities is provided by LangChain, as it is implemented in a chain basis. This pipe symbol will execute the functionality in a sequence, in a series way. Once that is done, we will be trying with explain about the feedback loops. As you see here in the PDF, we do not have feedback loops in any of the sentences, but it will just give us a walkthrough on this workflow maybe. And as you see, so let me just rerun this. This will take some time maybe. Yeah. Yeah. Was it fine? So only the final execution should be run. As we have invoked some sleep for 10 seconds, so it may take some time here. Rest of those things will be executed right away. And maybe in the meantime, do you have any questions on just whatever we have seen thus far on unstructured? yeah, those things will be covered as text-based content. So this will, when you see the response, just a minute, it will have the metadata as well as the image associated to it. So that's where we are using this function that has the image as well as the text, okay, which is extracted from the under that image, the captions or the figure number or the table number, all those metadata will also be appended here. So this function will give us, like, this is not just a text that has been fed into the vector store upon embeddings. This is as a dictionary, it has been converted into vectors and it has been stored, which has the similarity between each other.
Can you show us the a place where you convert the vector data into a text, back to text before sending it to LLM?
Yeah. And this is where we are having it. And text, so like all these will be added like within this thing. So we are not extracting the vectors and converting the vectors into the strings or the text, but here the functionality that is provided by string output parser, that will do the work here.
So it will take care of extracting the data from the vector and passing it to the LLM, is it?
How the workflows will be like, when we are feeding a new PDF, it will be converted or it will be passed into a text-based content. Any of the libraries we use, if you perform OCR or something like that, finally the input will be like text-based content. Okay? Yeah.
No, I understood that part.
Yeah.
My question was like, say, once the PDF is okay. Yeah, go ahead.
I'm coming to that. After converting the text, and it is upon applying like the embeddings here, it will be converted into numbers, and that is stored in the vector store. Like while retrieving or while generating the response, we already have numbers here, and we need to apply the embeddings again to find the similarities between the text we have passed as a prompt. Okay, and it will be comparing it with the vector stores that we already have, and that will be done by the LLM here.
So it will be part of the the chain that you use, right?
Yeah, like this chain. Yeah,
the chain will have both LLM reference and the vector thing together, right? So it will figure out what text to extract, right?
As you see here, like this function above, this function is having the LLM called chat OpenAI.
Got it.
And
yeah, I missed that.
This is added as a part of this chain as a runnable lambda. It will be automatically executed, and the model has been passed, and output parser. This parser will take care of the parsing of the final response.
Got it.
Yeah.
Okay. My second question is, how do you stream the output? I see that this output is streamed, right? Like, do you say it somewhere that the stream has to be, like, the data has to be streamed?
We are not streaming. Streaming is just like a visually appealing thing, right? We are not streaming it. We are getting a response as a single go, and we are just having it. Streaming is something like we can, like maybe as an enhancement we can have it, the streaming. But streaming is not a big deal here. Like we are just chunking the output container tokens, and we are just on a timely basis we can give us the response.
Got it.
Streaming is just like a logic we can apply or not. Yeah.
Got it. Thanks.
Any questions? Maybe it is not executing. Maybe just give a minute. Any other questions, guys? Please.
Excuse me. Is this available as an application? Do you guys sell this?
We will be sharing you the source code right away after the session. You can just play around with it.
Okay.
Farook.
And will the, meaning when we ask the question, will the image also come in that? With the
no, not really.
Okay.
That was actually one of the use cases where we are working on currently.
Oh, okay.
So we, as Kumaran said, like we got the references, page number or figure number, all those references we have got.
Okay,
but we also need to embed the actual image so that it is quite easy to interpret, maybe for the users.
Yeah.
That is what we are working on. Maybe for the next session we might have you there.
Okay.
Yeah.
Thank you.
Yeah, please.
One clarification, Farook.
Yeah, please.
You have the extracted description from the image, right?
Yeah.
Actually, this description extract from the text basis content or only the images?
It is considered as text, like as a composite element.
Got it.
Yeah.
That's only thing.
Yeah.
Thank you.
We like, why have we gone with unstructured? Why haven't really stick with document AI or any of the OCR services that is available in the market? The reason is we have got a use case that needs to extract the text content in the image as well. For that reason, we have gone with OCR. But to illustrate the image that we have, to get the summarization of the image, those things we still need to work on, and that's why we have gone with unstructured. So there were two use cases where we leveraged both of the services.
Okay, if it's possible to extract the description from the image without any text-based content. For example, if you only the flow chart.
Sorry, yeah.
Sorry, in image 3, you have the flow chart.
Yeah.
The flow chart explanations available in below the some paragraph is there in your PDF.
Yeah.
Okay, most probably our model will be work on based on your text content. The image description will be explained from the model. I have on the query, without the text content, only the image is there. So based on the image, the model can able to give the descriptions or not.
Yeah, we can do that.
Is possible?
Yeah, it is possible.
When while compare with the model given description and the description present in the PDF, both are similar. Did we check it out?
Yeah, that is what I'm going to cover in a few minutes.
Okay.
All those will be considered as hide embedding. Those were the enhancements we can apply in order to better chunk the content that we have and get the best out of it, or to minimize the usage of the knowledge base. Maybe like here we will be generating a response with the, or generating the questions with the content we have. If some question has been quite similar to what the question has been generated by the model, it will just relate or find the similarity between that, and it will get those relevant response on that. Yeah. What he said is like the image, can we get the description on our own?
Actually, for figure 3 in your model, it shows the description about the images.
Yeah.
In description, okay. The flow chart this. Okay. For this chart, model gives us some description, output. Okay. These descriptions will be present in your PDF in text basis, somewhere else.
Yeah.
Okay. Am I right? Without the text, I only given this image only, not overall the PDF. Inside of, I just given the image through the model without any reference. Our model can, based on the image only itself, it can do the analysis or not.
Yeah, it does. It does. This is what kind of doing it. Like, this is what we are performing here. We are not storing any of the metadata of that image. We are just storing as an image. Okay. And this one is summarized as a text.
Okay, if it's SMS is quite interesting. I want to need to learn.
Yeah,
I will check.
Maybe like unless and until it does, if it has enough information on that, it can describe.
Because of while I'm trying with only the images without any reference data, it not able to give a description about this data images, because without the description, model cannot able to identify what the image is trying to telling about. Even though there is a looping is there, the decision making is there. So model itself, they can't able to understand what is the decision making. Even though if it's a simple for loop, how many times the loop will be going to executed within this image is not able to do it. With the help of paragraph, it made the figure is a 3. Model will be check the figure 3 relevant data which was present in our PDF. Based on only, it will be generate the descriptions. So this is what I understand it. So if only the image basis, if the descriptions will be happens, it was quite amazing on it.
What you have understood is correct. Maybe the images that you have dealt with does not have the enough content on it. In this case, it is having the entire as content as in form of text. So you can easily figure out all those feedbacks and all those that is quite relevant to what is in the content of the image, like in the PDF as text. So the feedback is resonating with the feedback loops. So in that case, it is easily interpreting here. But the image that does not into the context, in that case, it will hallucinate. Maybe it does not provide enough context in it.
Okay, thank you.
Any questions? Maybe the code sucks.
Excuse me?
Yeah, please.
Oh yeah. Oh yeah. Yeah.
Yeah.
No, one more question is, can we? You're reading only a PDF file. Can we read other types of files also?
Yeah, we can.
We can read.
Yeah, we can.
And let's say you're reading only one file. Can we read like 10 or 20 files and give answers based on all the files? Meaning, in this file, this is coming from, and can we?
Yeah,
that
we
also?
can.
Okay.
That is what we need to apply chunking strategies there.
Okay.
Even if it is a single file or if it is a like a group of files, the final content is a chunks in the form of text.
Okay.
Even if you are feeding a single file, it will be into chunks.
Okay.
So in that case, just a text is the main deal here.
Okay.
So if a file has been fed, and it will be maintained in a hierarchical format. So the main document, and it will have a multi-layer, and the hierarchy goes on until it reaches the end and finds the final chunk that is quite relevant. Okay. So the same applies to the large or a number of files that you have. Maybe if everything is correlated, and it has a siblings node, and it will follow the hierarchy. In that case, all will come under one topics maybe.
Currently, that is not being
That
done
is
away,
not.
but
This is a very naive RAG implementation, but we will also need to work on all those advanced techniques as we move forward. Yeah.
Thank you.
Any questions? Maybe let's check now.
Excuse me.
Yeah, please.
Assume we have two files and a customer has a restriction on only one file. So is it possible to vector index that particular file?
Yes, we can. But based on the like we are vectorizing, we are not vectorizing on a role-based fashion maybe.
Yeah, in this not, but in Azure AI we are doing that.
We are actually like those things will be come under logics. Like all those will be converted into vectors, and all those will be stored in the vector DB. In this case, if a person is authorized to access those content, can be logically make them access only to those vectors that has been stored with some references, like I said, like hierarchy. So in that case, we can leverage that. But the content cannot be or like vectorized in that way. So everything will be vectorized as a similar fashion, but the authorization we can restrict to access, to make the user access to only to specific content. But what you have just asked is not done in the RAG process.
Okay.
Yeah. The application level. The application level authorization that I am saying. Yeah.
So there could be 10 documents as he said, but I expected to only reveal only one of the document for my end user. So should I allow that particular row or the index or whatever, right, to the particular user? Or
yeah,
we can do it at the Postgres level, I'm asking, because you are telling Postgres is a vector store, right?
Yeah.
So can we do at that level So that
while retrieving, we can do that. While generating the response, we can also feed the role of the user or under which category he may belong to.
Correct.
We can send them as user prompt and we can get the appropriate answer only specific to that user who is authenticated to access that.
Yeah, other things we can make it as
Yeah,
out
we
of
can
context.
do that, yeah. So all those will be coming under, maybe it can be handled by any of the frameworks like Llama Index or LangChain. But while creating vectors, we are generally creating the vectors by applying all the chunking strategies and all those. But while retrieving only, we will be applying all those restrictions. So just a minute. No. Maybe like let us move on to the next session. In the meantime, like let me also rerun the entire Jupyter Notebook. At the end, I will show you the demo. And let us get into some of the important techniques that we need to follow. Since this is a very naive implementation of RAG, we haven't implemented all these techniques here. So like as we move forward, we can also demonstrate in the further sessions by applying all these advanced RAGs. These are the concepts where we can leverage and where we can implement all those techniques to improve the retrieval process, chunking process, and the response generation process. And all those techniques have been segregated into 4 types. One is pre-retrieval data indexing techniques, and second one is retrieval techniques, and post-retrieval techniques, and finally generation techniques. Pre-retrieval techniques in the sense, if you are feeding a document and the document is not yet parsed or converted into some other format. So those were the pre-retrieval phase, maybe at the time where we are parsing the content, or at the time where we are performing OCR or some other process. So it does improve the quality of the information and the better retrievability of the information from the data source. In this case, not only PDF, we can also connect it to APIs. Like if you have wiki pages in Confluence, or if you have wiki pages in some other services, we can get those contents via API and we can feed into our RAG system. And those things will also have images, architecture diagrams, and all those instructions and all those things in the form of different like multimodal content. And all those will be chunked, but it is before getting into chunk, we will be like performing all those pre-retrieval techniques here. And it depends actually on the nature of the source and nature of the size of the data, all those things. So the first one is increasing the information density. So density in the sense, let's say I have an example here. Since all of the LLMs will take the content, most of the contents from the available internet, the very open internet. In that case, if you are performing some web scraping, in the sense it will be extracted in the form of HTML content. And from there, all those HTML tags will be removed, and that does not give us a proper information from the content that we have extracted. And what we have to do here, we need to also summarize those content into a form of separate entities that has the summarization of all those content. So that has been, as you see, so we here the model is GPT-4, and we are just feeding the content, and in this way it does have only the text only content, no list or no other thing, and this has been converted into in this format. If you see, the raw HTML has been converted into without HTML tags, and then finally maintained in the form of a proper informative sentences. So in this way, we are not yet chunked, or we are not yet convert them into vectors. But here we are just forming a sentence that further converted into vectors. So that is one way. And the next technique, so as you see here, like whenever you are not having the so much density here, what RAG does, it will generalize entire content, it take entire content into count and produce a response out of it. Whenever you feed the content again and again, the same large content again and again, the tokens number is large. In that case, cost will also be lost. The earlier use case, what we have just dealt, right? So those things have one chunk. We are not chunking it. So all those PDF have been chunked into one. If it has 10 pages, all those 10 pages will be considered as one text finally, and then converted into vectors. Here, we are segregating into summaries, and from here we will be converting them or chunking them into different entities and converting them into vectors. And the next one is apply hierarchical index, as I've just said. So hierarchical index will be easy for retrieval, in the sense if you have used some search, like if you are using keypad in your mobile, if you are just typing GOO, it will auto complete with good, or afternoon means AFT, it will auto complete with afternoon. That is data structure that has been followed. That is also a hierarchical pattern. In a similar fashion, when a LLM will interpret the response or the vectors, it will also easy for us to just focus on one hierarchy, not to generalize the other hierarchy. We can leave out them, because the question we ask is quite relevant to this hierarchy. So in that case, we are making it quite easy to interpret, right? Yeah.
What is the decision-making logic that arrive on the vector?
Yeah. Here we are not yet chunked here. We are just converting the unstructured data into a data that can be used to get the most information out of it. So that is the process here. As you just asked about the chunking strategy, we have, yeah, so on what basis we are making the chunks? That is what your question is. Vectors, vector space, yeah. So those things are calculated in the form of cosine similarity. Cosine similarity in the sense that is the distance between the, yeah. So in the application wise, we are just feeding the prompt to the LLM. The prompt is like the LLM is taking care of all those process here. We are not deciding like this is a strategy here. We are not doing that. We are just giving a very appropriate prompt so that it is followed and followed by the LLM. In that way, it responds to our knowledge base. Like in this case, we are having everything in vectors. LLM. Yeah. So the main difference you need to understand here, rather than using ChatGPT and the RAG system here, ChatGPT, you are not feeding any new data. You are just leveraging the potential of the model behind it. In case, like if it has GPT 3.54 or Vision, anything of it, right? But here, you are feeding your data and you are making vectors out of it, and using those vectors, you are extracting the information, the responses. If you are going with any business use case, you have to go with company specific data. In that case, the company data may have structured way, or it may be unstructured. So all those data we need to extract the right information by not losing any of the information or having some duplicate information. we should restrict all those before converting them into vectors, right? So those were the processes we need to focus on here. Those were the techniques that we are talking about here. And before converting them into vectors, are we having appropriate data here? Then it is converted into vectors, and all those vectors will be placed in the space. So all those related chunks will be in a closely related space. If any question is given into the LLM, the question will be placed in somewhere in the vector space. If any of the nearest or the most similar response will be retrieved, and that is further summarized and give us a response, or parsed and give us a response. This is the process any RAG system would take care of. But as an engineer, we need to better make use of these better, these strategies we need to apply on chunking, on parsing, on converting them into vectors, all those things. And yeah, so as I said, it is a multi-level, multi-layer hierarchy retrieval systems. That is the technique too that we can apply to our RAG, not just by simply converting the content into vectors. So as you see here, so this one is the first is like we have separated into different positions, and all those index will have n number of the subsets. So if it is having if the second tab is has the questions or the content relevant to the questions that we have asked, what are the chunks that needs to be considered here? All those will be only those things will be taken in count, rest of those will be left out, and it is applied on top k relevant chunks. And the next thing is retrieval symmetry using hypothetical question index. So here, not just by summarizing the content, but also we are generating a questions for those contents. On the right hand side, this is the content we have extracted from the web scraped content, but we are making the LLM to generate a question for this content, what the question could be, so that user question is quite relevant to the question that has been generated by the LLM. We are also using that thing to easily find the chunks that is asked by the user. And deduplicate the information. Here comes the overlap. If you have come across the overlap in the any of the RAG systems, so the summarized content or the chunks does not have the tokens or the content that is already chunked by another sentences or the information. So in that case, we need to either keep this or keep that. We should not duplicate all those. We should also restrict those. So those were the things we need to consider while building the RAGs. All these will come under data retrieval or pre-retrieval process. And finally, we are going to go with the chunking strategies. Okay, so what are the chunking strategies we have here? In order to chunk the data, we have got the data, and it is in a summarized way with all questions and answers, and we need to chunk in a way it can be stored into vectors. Yeah. No duplicate data, yeah.
Maybe 60% text is similar or 70% text is similar, and sometimes images are there. So it can be a HD image, or similar image. So how you make the decisions when you are creating a chunk and discarding one set of data and preferring other set of data?
Yeah, here actually the decision is not made by us. We are just instructing the LLM to perform in a way that it not take the duplicates. So we have a function called overlap here. Overlap, if you give some counts, so the overlap in the sense if 20 tokens, let's say overlap is equal to 20. So 20 tokens that have been already in the same, maybe in the same existing chunk, if it is also placed the same in a similar order, those things will be neglected. So those were the things that we can do using the frameworks like we have LangChain or Llama Index. But the decision, those things are made by the LLMs. So we are not actually deciding, so this is how it should be. We are just leveraging the decision made by the LLM. Here again, there are times the same sentence can be rephrased in a different way. In that way, we can just get to go with the same implementation. So we are not actually deduplicating there. Okay. So the first thing is fixed size chunking. Like we will be setting the token size, and that basis it will be chunked. So and the next thing is content aware chunking. Like one of the questions we already got, if you have the layouts as newspaper, how are we gonna deal with those? So we will be separating them using some splitters. Like in this case, we are making the RAG to perform the chunk on a sentence basis. So how you differentiate a sentence? By some separators like dot or semicolon, something like that. And the next thing is we will be performing the recursive chunk. It is applied to hierarchical node parser. So those things will be leveraging this recursive chunk. The entire large chunk is converted into converted into smaller chunks, and all those references will also be kept in the preceding chunks. And the next one is specialized chunk. So those like the question you have asked, right? The layouts. The chunk is converted into a different format. If it is having a structure in a way, it should be taken care. It should be take those things also in count. In that case, we will persist that structure here in the form of Markdown or in the form of LaTeX. So in this case, we are not cutting one half as a different and another half as a different. If you do that, it will miss out the most important informations if it has. And finally, semantic chunking. And also we will be applying the semanticization if it is closely related to each other. So the chunks that is has the meaning, the segments in the chunks has meaning to one another. We are also checking that. That is done by the semantic chunking. And after chunking is done, so the next thing is retrieval techniques. So this is done in the time of inference. When you are like making the vectors before converting the vectors, so you have to infer the data and convert the vectors when you apply embeddings. In that case, these retrieval techniques will be applied. One is optimized search queries using LLMs. You are training the LLM model to perform in a way, as Maha and Oliver rightly said, you have to instruct the LLM to do in a way. You should not please or you should not request the LLM to do. It will give so many suggestions in that case. So first we are setting the LLM by giving some optimized search queries. So you are just explaining the role, what is the role you are going to play, your document AI assistant, and you have to do this. In a way it will perform. And the next thing is fix query document asymmetry with hypothetical document embeddings. This is the other way around where we have generated questions for the summarization we have got. Here what we do here is, if a user is giving a question and we are looking the question into the vectors and we are getting the response, the first standard way. The next one is the question is convert, or LLM will generate the response on its own for the question. If the response is not in our database or not in the knowledge base, then it will check the answers in the in our vector DB. Maybe in some case where you no need of knowledge base, you just need the help of LLM to respond. In that case, you can easily not involved in this process of comparing the question similarity of the vectors that you have stored. So this will give us it will not move us to the final way of extracting the data from the vectors. So the next thing is query routing. So it is also applies to the same thing. So when the current chat conversation does not requiring any LLM call, then it will decide whether can I go and make an LLM call or query the database that I have. If I don't want to do that, I will not do that. So I will give you the response from the LLM itself. So this is query routing here. And after giving the response, after extracting the response out of it, right, before finally generating the final response, we are going to perform the post retrieval techniques. So here we are performing the prioritized search results by ranking all the chunks that has been considered for the response, and again we will be performing the ranking which one is so appropriate to consider as a final response. And the next one is contextual prompting again. So is it within the context of the question asked, or is it within the context of the chunks that have been considered? All those things will be considered here, right? It will also reformat in a way it is give us the response. And finally the generation techniques. So as we have already said, the chain of thought. If you have a series of steps, you can instruct the LLM to perform in a step-by-step way. So all those come under chain of thought prompting. And as you might have recollect what Oliver has said on like evaluating the RAG response. If you have come across Hugging Face, you might have some papers like LLM as judge. So those papers, like that particular paper LLM judge, will have an evaluation phase where it will always evaluate the response that has been generated by the LLM. If I'm applying some healthcare use case, or if I'm applying some other document use case, in this case, is the response generated by LLM is relevant, or if I need to generate again, if I need to reiterate the same process again, all those evaluation will be considered in the self-evaluation or using self-reflective mechanism. And even if you perform all this, there could still be this consideration. So it could be in a smaller extent. It could be like it has hallucinations, but the rate will be quite low if you apply all this. And you should also be aware of the input-output guardrails. Whether is this quite relevant to the questions or not. It could still be some derailing of the response which user has asked as a question. So all those things have to be considered while we are building any RAG model. Maybe you please scan the code. All the code base is in the QR code. You will be getting the GitHub link, and you can play around with the code that we have just implemented. And any of the new code that has been yet to be committed, like we will be do that right away, right after the session. Yeah. Yeah. So finally, Maha has come up with the response. Thanks. I will stop sharing. And as you see here, this is, yeah. So this is the response. This is the questions that we have fed, and this is the response we have retrieved from the image. The image predicts the semantic representation of all those feedback loops involved in this, and it will give us a detailed explanation on the image that we have got. So let's say yeah, I got it. So this is the visual representation of the image, and this is the content that is going to illustrate all the flows of that image, and again explain the receptor in the human skin. this content is relevant to the human skin receptor, and it is segregated into hairy skin and glabrous skin. And so this will be image also distinguishing this one. It also includes the content as well. It is not only taking the image in count as you have asked. So this is what we have for the session. Maybe I'm done with the code walkthrough and as well as the techniques that we can implement in order to better the RAG process. So thank you guys. Any questions as we move forward? Yeah. Mike.
So what the document AI extracts, so that is like just converted the entire image bytes into PNG for you. So you could see it here. So the JSON file, I have used a simple JSON file. This is the JSON file I have used here, and this is got converted into, I am just using the content part. Yeah, you could see it here. I am using the content part here from the image bytes. This is how the entire content is like converted into image using image bytes. So that is the one part, and then the same with the document A. We cover that. So it is same thing like what Farook is explaining on the loop structure on the workflow. So he explained feedback loops of signals for the person and control of the limb movements. You can see, right, it refers the figure 3 image. It refers figure 3 image and like drives by step, like what each signal, the arrow mark, based on the arrow marks, it provides you the complete details, right? Of course, right, it may not be completely correct. There may be some hallucination, but we can slowly improve on. So the technology is getting promoted, like it getting advanced every time. So honestly, like the code what we used last month, we cannot use this month. So you could have seen, like those who are working with all the AI latest library, you could experience that it is enhancing more. So the latest technology is coming at large phase. So every time, like it is like a advantage for us as well to get rid of the hallucination. So everyone, like you could share your thoughts and you can share your experience. And like we also have no issues. Sorry for that.
Sorry.
Yeah. So we also have our own Instagram, and through AI Connect, you can also post it like what is your experience with handling the OCR tech stack, along with like one of the challenges we also discussed. So when we are working with this tech stack, right, how we going to relate the images? So because this unstructured splits the entire PDF into elements, text as a separate element, image, table into separate element. At least like table, we have the text part, so which we can correlate with the actual content. But what happened to the image? So if we are not able to read the labels in the image, how we can do that? So one of the way we just figure it out is, right, using vision. So we have a ChatGPT vision and we have a text AI vision. So where we could summarize all the text in the image. And when you summarize, you create a context. Already you have a text. There you have a context referring to the figure 1. Similarly, like when you summarize the image, you get a context. So that is how we chunk, like we merge those data to the relevant context. That is the one of the practice we follow. maybe like it is not 100% perfect, but it is gives like it works somehow. So, but every time we are working on some improvements. So you could also share your thoughts and share your experience through Instagram, through AI Connect, and we can also get connected after this session, so how we could improve more, right? So thank you everyone thank you for time, and with respect to Talentship and team, thank you so much for being part of this.
Thank you, Mohan. The questions you have.
Yeah. So I have a doubt regarding the model we use for this RAG.
Yeah.
So earlier we discussed that there are two types of models, like open source and closed source.
Yeah.
Regarding closed source, it's not much of an issue. We just get the API key and make API request. So it's a easy task only.
Yeah.
But regarding open source models, we have to download it, do some installation, and then we have to do it.
Yeah.
My doubt is when I'm going for deployment, let's say I want to convert it to an HTTPS application, how do I do with open source models?
In that open source, like you need also to provision the machines in order to run that model. In order to convert all those, like it will perform all those billions of parameters. So all those models will require high computing maybe device. So you need to provision that.
Okay, in my case, let's say I'm using Olama, and I need to deploy it in GCP or AWS. What?
Yeah, for
like
that,
how do I do it?
You need to deploy it in a server. Maybe you can go with some, if it is AWS, you can go with SageMaker or something related to other thing. Like if you have Azure, you have similar services there, and in GCP you have similar services there. So to deploy all those high computing LLMs.
Okay, so basically I have to provision a VM and do the installations.
Yeah,
and
so all those you need to take care of on your own.
Okay.
But the closed source, as Oliver mentioned, like you
We have
will
to
be
make an
getting the
API
APIs
request,
as
yeah.
you pay for it.
Okay.
Yeah. Any questions, guys? Yeah. Like we are working on different technologies now. Like we are working on TypeScript and JavaScript, but not on this AI space. Since all this RAG process is quite have a good community in Python, so we are just going with Python. But we are having a product that leverages all this RAG. That we are using Next.js for the front end and TypeScript stacks, but not on AI space. So since Python is quite easy to get the questions answered, since the community is big, so yeah. Any questions, guys? Maybe we can sync up later while we network, so we can also discuss what you guys have implemented. So you can just connect like in any social platforms with the fellow engineers here, like you can, and just share us your work by tagging us if you really want to explore more of the things. Thank you for your patience. Thank you for being an amazing audience.
So yeah, thank you Maha, Kumaran and Farook for an enlightening session. Really, it was very interactive. So before winding up the session, we'll just have 10 minutes of breakout. How many of you are familiar with Connection? Yeah, almost everyone, I guess. Connection game. Yeah. So what we do here is we have like 9 set of connection questions, everything related with the AI terms. So if you want to guess, a clue is everything is related to AI. So what we do here is, so for each question, each row will get a chance. For example, the first question, the first row, that is the 2 set of row people would have an opportunity to answer. If they fail to answer, it would get passed to the next team. So only that particular team needs to, like any one of them can answer it. If any one apart from that team answers, you are not into consideration. Maybe that team who is into consideration can take that as a clue and can answer. So it's a win for you. Am I clear with the things? Maybe we'll take 2 more minutes for people who went out to settle, and we'll just start with the connection. So it's simple. We have 9 set of questions. Each row will get a chance for their turn. If they misses, it will just pass to next team. And it is an individual contribution, so anyone who knows can answer. Only that particular team can answer. So if anyone apart from that team, yeah. Yeah, it is a sample question for information. And yeah, and I could see like everyone out of excitement is answering, but the first, for example, the next question, it will be only for the first row. So the people from that row alone can answer, and if they can't, it will just pass to the next team. Yeah, if anyone got excited and answer, you won't get the gifts. That's it. So the first question goes to this team, and anyone from here can guess an answer. So the clue is, it's everything related to the AI. So all the terms are related to AI. Yeah, so these 7 people are entitled to answer this question. Okay, shall we start? And Sudha, can we have like 30 seconds? Can we have 30 seconds for them to guess? Minute. We'll try for 30 seconds. If this works, we follow, else we can have a minute. And if you fail to answer, it will pass on to the next relevant team. So mostly it's first, second, third, fourth, and you 5 people will be one group, and another group, and similarly it goes. So are we done? Shall we start? Yeah. Yeah, it's anthropic. Your name? Sri Hari. So Sri Hari answers it correctly, so it's anthropic. And another thing, like I said again, whoever is entitled to answer, let them answer. I could hear someone answering it earlier than him. It's again, the relevant row can get that and they can answer and win. So try to just control the excitement, and please do answer when the turn comes to you. Okay, to the next row. Yeah, the second question to that row. Yeah. Talentship people are not entitled to answer, please. Please do answer, like if you have a hand mic. What is the answer? Dolly, yeah. So the next question. So I give a clue like how it is created. Either it could be like the words or the images, or how, like you can just relate and...
Tokenizer.
Sorry?
Tokenizer.
You're a bit close. You could try the...
Tokenization.
Yeah, it's correct. It's tokenization. Huh? Yeah, it's the right answer. Shall we go to the next question? Sudha? Yeah, the next question. I could hear, please do control excitement, guys.
Extraction. Extraction.
Yeah, it's correct, it's extraction. Yeah, I can understand you're all excited, but still, we need to win this game, no, guys. Yeah. No, let them answer from there. Is it visible? Over there. Sudha, shall we move to the next question? Yeah, next question, Surya. Those who find the answer, please do tell in the hand mic. So it's fine tuning. So the next question.
Neural network.
Neural network.
Yeah, it's correct. It's neural network. Yeah, the next question.
Big data.
The excitement never goes off. Yeah, the answer is big data. Yeah. So the question to the next group. Yeah, it's large language model. Guys, it's really nice to see like it didn't pass even to the next group and you guys are able to find it very easily. I think I should have like made something more complicated. Yeah, so the last question of the connection.
Semantic.
One more word left. Who said that? Excited again. Yeah, it's right. It's semantic analysis. So thank you guys for your participation. Yeah, to make this event more memorable, and we are so gratitude for the speakers who spend their lot of time in creating all these slides so that it could be more useful for the attendees. So in order to make that more memorable, we like to facilitate them with a small memento. So I request Pavitra to facilitate Oliver as a token of gratitude, please. We thank you so much, Oliver, for traveling all the way for this enlightful session. We love it so much. Yeah. We are glad that you love it. I request Mohit to give away the memento to Maha, please. Thank you so much, Maha, for the great session. It was very much enlightening and useful. Thank you, Maha, and thank you, Mohit. I request Bala to give away the memento to Farook. Thank you, Farook and Bala. I request Surya to facilitate Kumaran, please. Yeah, to make this event, like, if we need to make this event even more big for the next time, we always need a feedback from the people from you so that we could take that as an input and we could make it even better. So I request like attendees, if you're interested, to share your experience here. Yeah, I request attendees to share your feedback here. Like if anyone is interested, can come and share your feedback here.
Okay, thanks for hosting this event. But in your agenda, you had a workshop, right? 1 hour workshop was there in the original agenda. But I think in the next event, if you have that as a workshop, it will be really helpful for us.
Yeah,
hands-on.
definitely. So we actually planned for the hands-on, but the response from many of them, right? So they are not very like they got like a few experience of handling the latest AI tech stack. So whatever we prepared, but definitely we will consider you. Like we are not going to stop it here. So we will have this continuity, like off-day workshop where everyone comes with your own laptop. So that's the reason we try to host it like as a hands-on lab session. But many response were something like they just want to start with. So like we want to target a right audience for the workshop. So once we cover with the basics and then give some time for them to also understand their latest, and then we can definitely like target particular audience who already have some level of experience working on Jupyter Notebook as well as the AI tech stack. So then that will make sense. But definitely we will give you a special invite for that. We are not going to stop it from here.
Thank you, I appreciate it.
So I would like to thank, because during my college days when I was studying AI, it was a fascinating subject for me. And although I am part of TSI, but it's as a attendee, I would like to share the feedback. It was a very nice session by Oliver, Maha, Farook, and with the good demo. And I really, it's again put my passion back for AI. So I am still remembering that project I did it, but I really thanks to Oliver. I had a word with Oliver yesterday, today also, even Maha. It's a nice session. I really appreciate and thanks. Thanks you all.
So, I know when we came here, three people, we planned to come here. When we registered for this session, we were in a small dilemma that, how will it go? It was a 5-hour session, but, after the whole event is done, it's a totally very good experience for us. The initial session on what is basically the latest trends in AI and what is LLM doing, what is GPT happening, that was very insightful, followed by the, hands-on which we did. Probably it's not 100% what we can try, but all the, examples and how it's been implemented, probably, everything was, properly planned, well done, the execution of the whole event and the content was so good. I know I'm literally impressed with the whole event. Thank you so much to all of them who did this.
Yeah, so first of all, wonderful session. I had so much fun here. After a long time, I'm actually coming to office space. I've been working from home for like quite 5 years now. Yeah, so any hands-on demo would be great. And if you can entertain us, like if we can present something next time, that will also be great. So yeah, if we could stay connected somehow, and then we could present our cases. Yeah, that will be, you could create a space for us to present something, right? So.
We are looking for like, more speakers in the future, so, because it is going to be a community, okay? So we need more speakers, and probably you could contribute. So in next session, as you also register, you can also show interest that what you want to present it.
Absolutely.
So definitely we like you, so you can present it next time. So
definitely,
come up
yeah.
with your own content, yeah.
Cool.
Very good.
Thanks.
Yeah, thank you so much for all your valuable feedback. So as Maha said, TAI Connect is not the community formed within the Talentship. It was though created from Talentship. It is in the aim of creating to have large community members like from various organizations. So we like to have more amount of speakers from other organizations too, so that we can have a better knowledge sharing. Yeah. So from my side, I need to thank the attendees for making the session more interactive. We just had like a few of the people who are more interactive and just throw all your questions and suggestions, all the informations that you have to the speakers. So we just like to give a small memento to them. Raja Bhupati. I request Maha to give away the mementos. Yeah, Sri Hari, I request Maha to stay, please. Sri Hari. Aravind. Aravind R. Aravind. Dinesh Babu. Yeah, Bhupati. And Mohit. Sorry if we have missed them. It's not intentional. Like we just saw from here, like whoever were interactive, we just try to give. Please don't get hurt if we miss few of you. And I request Oliver to share his experience on this event.
Thank you, Devi. So I would say this was a really great event. I really liked being here. Yeah, I really like that we're at a starting point of a new community. And therefore, in the future, I would like to really invite everyone to come here, become a speaker, share their experiences, because that's basically why you have a community. It's to network, to actually see what other people are doing, to learn from each other. And I like to invite all of you to be a part of that. Yeah, so we actually was just the starting point, but now it would be really nice, to learn from your experiences and from your learnings. Yeah, not everything goes always well. I think it's always good to share the good and the not so good experiences so that other people can learn from it. So I really hope that this will be the starting point for a really engaging community. And I'm really looking forward to see many of you as a speaker here, hopefully very soon when we're going to host the next event. And for now, I would say thanks you all for coming. I hope it was worthwhile being here, and really looking forward to seeing you here next time. Thank you all.
Thank you so much, Oliver. I request Balu to deliver his thank you note, please.
Guys, good evening. This is the true thanking note, okay? All these guys say thank you, thank you, thank you. At least 20 thank you was delivered. But this is a true thank you note, and after this, you all can go. Right? Because I can see you all packing bags, half going, half coming in. I was scared when I was delivering thank you note. Probably I will not have anyone here. But at least Devi ensured everyone sitting here. Great, thank you for coming. I strongly believe time is the biggest and most valuable commodity. And you all thought that today you want to invest your time here. Great Saturday today. Weather is awesome. Rather going to a movie, rather spending with your family, you all thought better be here in Talentship, better invest in AI, and better be here. And we hope we have not disappointed you. And I can already see from your feedback that you had a great time here. And as Oliver and Maha have said, this is our first AI event, and like maybe some of you have attended our previous events in React and few other topics. We would continue this AI event furthermore, and we would love to have you guys as our partners here and deliver further more speeches and have more channels in terms of delivering more breakout sessions and focused workshops in AI. We would love to have you back here, and we will have more concentrated sessions on AI. So a big kudos to you, big thanks to you, and please have pat on yourself for being here and delivering this. Thank you for being here. My second thanks, yes please, you know, it's 5 hours. Yeah, when I was young, if someone says 5 hours session, I would not go. Yeah, truly, yeah. I'm basically a technical guy. If someone says 5 hours session, probably I would say, no man, I will go for a movie. Yeah, but you guys sat 5 hours, enjoyed 5 hours, so thank you for being here. My second biggest thanks is to speakers, especially Oliver. When we said we want to do something like this, when it was coined by our team, he said, yeah, I will be there, I will deliver a speech, and I want to do that. And knowing Oliver for long, I know he's very passionate about all these things. But we were little scared, and you know, having him to deliver a speech or to do such sessions, we're not sure about the audience, how they will take it, how it will go. But again, you know, it was fantastic. You being great audience, he being great mentor, it all turned to be an awesome thing. And thanks, Oliver, for being here and delivering this. And again, big kudos to Maha, Farook, and the whole team for transferring the knowledge in a more practical way, because just PPT and slides would not deliver values. You can see them in YouTube nowadays, or probably ChatGPT can answer all the questions nowadays, right? But having it a little more deeper and hands-on would give you more insight to start your own stuffs. So again, thanks Maha and Farook and the whole team for doing that. And big kudos and big thanks, because for us, we want to do more of such sessions in different topics, not just AI. And we want to do this in the best possible way in Chennai. We strongly believe Chennai needs such big communities and big platform for people to come and enlighten themselves with new tech stuffs. To do that, we need a great volunteers. And for us, the volunteers are built by our staffs, by our own family here. I call them as my family. And what you see here is done and delivered by our own people. And they have spent their Saturday and almost last 15, 20 days planning this event. If you see anything here, which is great, everything is great, is done by them personally. Nothing is outsourced, nothing is given to third party. Everything is done by them. So probably you guys can raise your hand, and you all deserve a big applause. Can you go ahead and raise Talentship volunteers? Go ahead, please. Come on, come on, come on, come on, come on, come on, come on. Mohit, you should also raise your hand. Thank you guys, thanks for doing. And special mention of Nitin. Yeah, you should. And then Sasi on back there. Yeah. And then our lovely host Devi, and then JP. Yeah, they did a tremendous job. Like Nitin, we have some digital things going on. This was a trial. We were also on YouTube. If you want to replay this content and see, there is a YouTube available on LinkedIn, our page. There is a link, I think. You can play the whole session on YouTube and revisit the content there. And this was all possible by this young chap. It was all his own idea. He brought it, and then he delivered it. There was no one else. I gave him this idea, but yeah. Thanks for doing this, Nitin. Yeah. Again, big thanks for you guys staying here so late and doing this, and have a great evening, guys. Cheers, and we will keep you posted. Yeah, keep you posted, and then please follow us here, and please share your feedback. Your feedback is important to us. Use the link, share your feedback, and give your honest feedback. Don't say everything was rosy, everything was good, thank you for your snacks, thanks for this, thanks for that. If you feel something need to be improved, be brutally honest and give your feedback here. Thank you, guys.
Thank you so much, Balu. So I'd like to extend my special thanks to all of you. And with this, we'll end our session. We like to have a group photo outside. Post that, we have a few more refreshments where you can collect. And if you wish to network, you can stay and have nice time. So we'll just have a quick group photograph so that people who have other plans can proceed. We also have refreshments outside. Please don't forget to collect them too. Thank you everyone. Thank you all to Talentship people especially.